So very good evening to all of you and welcome to this very amazing sessions by your one and only chemistry expert Sanjay Arya sir. So we were continuing the PYQ series from 2002 to 2025, and in this very amazing session we will be dealing with very important topic, a very important chapter from inorganic chemistry, which is chemical bonding. So bonding itself is a huge chapter, guys. Weightage wise, it's very big chapter and it has so many concepts, and that's why I took two lectures consistently. Chemical bonding part 1, chemical bonding part 2. Please visit those chapters if you have directly come over here or you want to go for its theory and the conceptual clarification. Please visit those two chapters, two lectures. Now let's come back to the session. This is where we are covering from 2002 to 2025. It's chemical bonding, and the very first chapter that the very first topic that we study among it is called as Cossell-Lewis theory. Let's start with the first question. This question in front of you appeared in JEE Main 2025 first attempt. So like this question came in the first shift of JEE Main 2025 and based upon Cossell-Lewis theory. So I find Cossell-Lewis theory is very important, right? Cossell-Lewis theory has been asked even in JEE Advanced 2024. So I can see that from chemical bonding, this basic theory, which is quite the easiest theory out of all the theories we study in chemical bonding, let it be valence bond theory, we have studied VSCPR theory, hybridization, we came to molecular theory. The most easy theory is Cossell-Lewis theory, the law of octets and drawing the Lewis structure. Let's come to the question. Question simply says match the list 1 with list 2. So let's match list 1 from this question to list 2, and molecules which are obeying octet rule. So where can you see the octet rule? Carbon compounds always obey the octet rule. Incomplete octet are AlCl3 and BCl3 with 6 electrons in their valence shell. Molecule with incomplete octet and odd electrons are nitrogenous compound, and especially the compounds which in total have odd number of electrons. Like look at this, nitrogen has 7 electrons plus 8 electrons of oxygen. 15 is an odd number. The correct answer should be this. And the final is molecules which is expanded octet, sulfur and phosphorus compound. 12 and 10 electrons are there respectively in the valence shell. So correct answer is known to all of you. This is how we have to respond. We were also supposed to pick the correct option out of 4 options given in the question, but right now as we do not have any proper options as such, so we'll just accept this question like this and we'll move forward to the next question. Now I'll be taking you to the next question that also was asked in JEE Main 2025. A question that appeared in JEE Main 2025. Hello Shrikar. So guys, please try solving these questions with me. Question came in JEE Main 2005, exactly a few months back. In fact, last month itself. Total number of non-bonded electrons present in nitrite ion, NO2 negative, we call it nitrite ion based on the Lewis theory. So total number of non-bonded electrons are actually lone pair or bond pair, only lone pair also plus unpaired electrons also. So nitrogen dioxide with a negative sign. So there could be 2 ways. One, we can make this like this, oxygen with a negative charge, right? And one lone pair is there on nitrogen itself. So let's see how many number of electrons are there. 2 electrons have been shared by oxygen, so these are the 4 number of electrons available. Then 1 2 3 4 5 6 electrons are over here because it is carrying a negative charge. 2 electrons are shared here. One of oxygen has a 7 electron over here because one negative charge is there. So 6 plus 1 7 is there. So this is how the electronic structure looks like. If you want to ask me like how many bond pair are there, so these are 1 2 3 bond pair, or yeah, bonding electrons are how many? If someone asks you bonding electrons are how many, so 3 into 2 will be 6. And the third thing that we have to find out, the only thing that has been asked in this question, number of non-bonded. So this is the non-bonded electron. So let's first find out the number of lone pairs. Number of lone pair. 1 2 3 4 5 6. So number of non-bonded electrons will be how much? Lone pair multiplied by 2. Let's say if there is no odd electron is there, that's why we are just simply taking all lone pairs and multiplying by 2. 12 should be your correct answer. I must check it. And 12 is the correct answer, guys. So be confident on what you opt for. Okay, always be confident on what you opt for. Shrikar, I think you missed some electron and that's why you submitted me 10 as the answer. No problem. Stay confident, man. Stay confident. Don't worry. And there is no need to hide anything. Just be clear to me. And even if you face any kind of doubt, do let me know while helping you out of any kind of question is there available for you. We have another question in the Lewis dot structure. Total number of valence electron around nitrogen. Now see another similar question. In the Lewis dot structure, and that question came in 2024. So see how important this compound is, nitrite ion. This question came in 2025 upon same nitrite ion. Another question came for same nitrite ion in 2024 as well, and has been asking about the total number of valence electrons around the nitrogen is. First, let me draw its structure again. I remember that's how we drew it. Like this. Now we got to identify the number of valence electrons around nitrogen. What is the meaning of valence electron around nitrogen? Total number of valence electrons around nitrogen. Okay, so like nitrogen is acquiring how many number of electrons now? See, this has been shared. This is 2 electrons. This is another couple of electrons here. Another couple of electrons here. These are the shared electrons. So total electrons with nitrogen over here are bonding electrons plus lone pair electrons. How many bond pair can you see? 1, 2, 3. 3 into 2 plus number of electrons over here in lone pair 1 into 2. So 3 into 2, 6 plus 2 is 8. I think should be the correct answer. And I think 8 is the answer, and 8, it is something that is showing that nitrogen has a complete octet over here. Right? Am I right over here? Okay, 18 valence electrons. Somebody is saying that, sir, no, it should be 18 valence electron. Not 8, right? So the only thing that has been asked is around nitrogen. I think 8 is correct answer. 8 is the best answer over here. Hello, hello. हेलो हेलो हेलो, मेरी आवाज नहीं आ रही क्या? Allow me a second, guys. Allow me a sec. I think now I'm pretty much audible, right? Yes, guys. So, okay. And I have seen like people have not liked the session. Okay, please like the session, everyone. And now let's come back to the question. Actually, the mic got disconnected, and that is why it took me some while actually to adjust it. Okay. Of course, I am here only, Shrikar. Let's see another question. The number of molecules from the following which are exceptions to the octet rule. Exceptions to the octet rule, whether they are expanded octet or they are having incomplete octet, everything comes under this example. So anyways, carbon compounds are always completing their octet. Nitrogen dioxide is there, and one nitrogen odd number of electronic is there. This is odd number of electron. This is expanded electron. Boron trifluoride has incomplete octet. Then ClO2 has odd number of electron. Beryllium fluoride, and this has expanded octet and this has incomplete octet, hypovalent and hypervalent. CaCl3, carbon compounds are always fine. So now let's see how many of them can you see, because I have seen 6 out of here, and this is the correct answer also. Okay, this is the correct answer also. 6 is correct. Let's see the another question. So please try this question, guys. Total number of molecule. Okay, you try it. Allow me a second. I'll come up with my water bottle and we'll be joining you shortly. Okay, please try this question, guys. Please try it. Yes. So hopefully some of you have tried this question. I got stuck in some work, and anyways I have come back. Let's see this question. Number of molecules or ions from the following which do not have odd number of electrons. The bestest ways odd number of electron to find out is count total number of electrons. Count total number of electrons if it is odd or if it is even. So if it is odd, then definitely it is odd electronic species. If it is even, then it will be even electronic species. So there we have 7 plus 2 times of 8. This is 15 plus 7 is 22. So not 22 here. 16 plus 7 is 23. Then iodine. Man. So there is a negative charge over there, no? Let me count the electron of iodine. So chlorine is 17. So 17 plus 18. 17 plus 18. 35 is of bromine. 35 plus 18. 53 is the atomic number of iodine, and that is the number of electron in it. Plus 4 times of chlorine has 17 plus 1. So let it come whatever it is, but I think it is even. This is coming as even. Right? This is odd plus 1 even, and this is also even. Bromine, we can also count the same. 35 is the atomic number of bromine. Plus 3 times of fluorine is 9. So 27 plus this, I think this is also coming up as even. Chlorine, 17 plus 2 times of 8. 17 plus 16. 33, which is odd. This is also odd. NO2 positive. Nitrogen has 7. 2 times of 8 minus 1. So this is 6 plus 22, which is even. And then nitric oxide is 7 plus 8 is equals to 15, which is odd again. So where can we find the odd? 1, 2, 3. 1, 2, and 3. I think 3 is the correct answer. Somebody has submitted me 3 as the answer, right? Sir, ICL4, BRF3 and NO2 do not have. Okay, thank you, man. Thank you. So we'll see. 3 is the correct answer. See, you try it by any of the way, you will anyhow reach to the correct answer. That is what I say. That's what I always say. You go pick any of the way, you will definitely be coming to the final answer as 3 only, correct answer. There are several number of ways to solve it. But now we have another question. Cl double bond in perchloric acid. So I think this is the right time. I should give you some more example on these kind of oxo acids formed by chlorine. What kind of oxo acid does chlorine form? Number 1 is called as HOCl. Or we can call it HClO, HClO2, HClO3, HClO4. Their names is this is called as perchloric acid. This is called as chloric acid. This is called as chlorous acid, and this is called as hypochlorous acid. Now identify their structure, guys. This is Cl, which contains OH like this. The correct basically structure is. So over here this is having C double bond O, Cl, and with one O and H. Rest will be the lone pairs over there. Then we have C double bond O, double bond O, one bond O, H, and there we have C double bond O, double bond O, double bond O, and one OH. Now guys, out of these all structure, we were about to concern or discuss about perchloric acid. So how many number of Cl double bond O we see over here? This is actually Cl, not C. 3 I think can be the correct answer. What do you think? Right? Can I see correct answer? 3. Is it 3? 3 is correct answer. Okay, right. It's very simple, man. So the only thing what a student will be facing, the only problem that a student will face is that when we start chemical bonding, we are right now in the start of 11th standard. And in 11th standard, usually we do not come across so many molecules that we are going to see in 12th chemistry or in inorganic chemistry. So basically 12th, if we say just about chemical bonding, is just the start of the inorganic chemistry from 11th standard. So that is why we sometimes fear from these very weird names of the compounds. But once you will be completing your P block in 12th standard or in 11th standard also, you will come across these kind of compound, and then you will become very comfortable out of these all. Okay. Now let me take you to the next question. There we had so many good questions on valence, what was that? Coriolis theory, that is winded up. Let's come to ionic bond. The another topic of the day is ionic bond. JEE Main 2024, a question has been asked in JEE Main 2024. Which of the following is least ionic? So anyways, these are the number of basically molecules which have been given to us. In order to find out the least ionic, what I am gonna to do, I'll first of all mark them as cation and anion. Okay, this is CO 2 positive, 2 Cl negative. This is K positive, Cl negative. This is Ba 2 positive, Cl negative, and there is silver positive, Cl negative, right? So we got to basically tell which of them is the least ionic compound. So first of all, you should know that we have to basically apply the Fazan rule over here. Fazan rule has to be applied. So let's see what Fazan rule says. So Fazan rule says that polarization, which is also called as the covalent character, polarization or the covalent character is directly proportional to, see, anions are the same only, charge of cation, which is always dominant over the size, so 1 by size of the cation, and also directly proportional to the pseudo inert gas configuration. Now we have plenty of things which are what I should say are contradicting. Okay, there are plenty of things that I find are contradicting. लहरा दो. So whenever this kind of situation comes, like this, I think I must give you a priority order to all of you. So the priority order is that pseudo inert gas configuration must come at the top, then comes at the charge, and then comes at the size. That is what we have to follow. The only pseudo gas inert gas configuration over here is silver Ag plus, right? Silver has what? Ag plus, whose electronic configuration is argon. So 3s2, 3p6, no, 4s2, 4p6, and 4d10. Because of its strong Z effective, it will be taking it towards covalent bond formation rather than ionic bond formation. Okay, hopefully this is absolutely clear to all of you. Shrikar, you have submitted the correct answer. Keep it up. AgCl is correct. Now let's see another question. There we have the another question, guys. Look at the another question. Arrange the bonds in increasing the ionic character of the molecules out of these all. So do you know what N2 has? N2 has 100% covalent character. 100% covalent character. Why? Because there is no electronegativity gap, and we can only see that percentage ionic character is directly proportional to the delta of electronegativity. Wherever there is a higher electronegativity gap, there will be the higher ionic character. So let's look at these examples and try to solve out. I think, okay, and let's see, if I talk about fluoride and oxide, oxide has bigger size. Also, the charge of an ion also matter over here. I think we have plenty of things over here. How can we decide it, man? This is most ionic. Because it has the highest delta of electronegativity. And this is the lowest ionic. Because there is no delta En, there is zero delta En. फिर followed by non-metal, 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 then metal and non-metal. But here this is if we talk about, there are two doubts we are right now having. One of them is K2, another one is lithium fluoride. Now try to simplify this thing over here, that this is 2K positive, one oxide ion, this is Li positive, one fluoride ion, and we talk about oxide ion. This is actually charge plus this is size also is of higher, so this is also an order of polarizability, polarizing ability. That's why K2O is lesser ionic than lithium fluoride, or we can oppositely say that K2O will be more covalent than, because charge dominates over size. As I told you, charge dominates over size. Charge is higher of oxide, and oxide will become more in size as well. So that's how I think A should be the correct answer. My pick is A. Let me see who has picked what. A. Okay, Shrikar has also picked A. Good guys, good, keep it up. Now I'll take you to the next question from here. I think A is the correct answer. A question that came in JEE 2023. Let's look at the question. Number of following factor that will affect the percentage covalent character of an ionic bond. Does it contain polarizing power of cation? Yes. Extent of distortion? Yes. Polarizing ability? Yes. Polarizing power of an ion? No. What is this polarizing power of an ion? Power is always calculated for cation. Here, what's wrong here? Polarizing power of cation. Number of following factors that affect the percentage covalent character in ionic bond. Extent of distortion, polarizability of an ion, polarizing power of cation. Why does it polarize? I don't get the question. I didn't get the question. Number of following factor which affect the percentage character of bond. I think 3 is the correct answer. Actually, this is not asking us about any, what I must say. What is it asking about? This is asking about the number of factor. And I think, let me. Now camera is looking better. So guys, actually the number of following factor that will affect. So I don't think this is a option based question, in fact, right? I think its answer should come in numeral. 3 is correct answer. I think this is some misunderstanding has happened, but we'll move forward to the next question. We have the another question, everybody. Please look at the question. This was asked in JEE 2021. The question is simple and says that the number of set of these compound which pairs are in the correct order of their melting point. So the melting point of the compound is directly proportional to their ionic character. Is proportional to what? Their ionic character. And now we can use what? Use Fajan's rule. We have to use what? Fajan's rule. So lithium chloride and lithium fluoride. Lithium fluoride has more ionic character than lithium chloride. This is not just ionic character, but also the melting point. So I think use Fajan's rule, LiF should be more than LiCl. Okay, now talking about, we have NaCl and MgO. As I told you, charge matters over size. This must have higher ionic character. So does the melting point. So here we can easily decide that lithium chloride more than lithium fluoride more than lithium chloride, and sodium chloride more than magnesium oxide will be the order of melting point. Hopefully you all have picked for the same. Hopefully you all also have picked the same, as I can read out all the comments. Okay, so that's it, guys. There is something not correct. Actually, pardon me, guys. Magnesium oxide is said to have the higher ionic character, even due to its higher lattice energy. That's how basically we have to think actually. The lattice energy. A compound with higher lattice energy is ionic character. Instead of that, we have to count its lattice energy, because all of them are ionic in nature. So lattice energy is the funda that we have to use over here, and lattice energy is inversely proportional to the size, directly proportional to the charge, and that's it. So I think magnesium oxide is having higher ionic character, and due to its higher lattice energy as well, and melting point will be higher for MgO, and correct answer should come up as D. As I can see, the correct answer also has been given D, right? So that was a good question, by the way. But again, I told you, these are some set of points where every student gets confused, and not just student, even sometimes teacher. As you all seen me, I also got confused there, because there are two things that are contemporarily, they are like contradicting to each other. One of them is called as the lattice energy. The another one of them is called as the I must call it the Fajan rule, which gives you the percentage ionic character. So there were several factors that we would have applied, but yes, talking about the melting point, we should rely on the lattice energy first of all, rather than going for the ionic character or Fajan rule. Let's see the another question. We have ion charges. So whenever two charges are there, so there, what is this interactional energy? This directly proportional to 1 by r, the distance between them. So I think first is matching with A. We have to match only. No, dipole is very what should I say? It's a very lesser quantity of the amount of energy that we see. The London disperses is directly to r to the power 6. Okay, that's it. I think the question was bigger, matching was required, and optional matching was there, which was asked in the question. We didn't have actually the number of options, so we are just leaving it like this. In dipole, if it's a static molecule, if dipole is a static molecule, then it is directly proportional to force of the interactional energy between them is directly proportional to 1 by r to the power 3. But if it is moving molecules are there, in that way gaseous molecules are there, then in that way we use directly proportional to r to the power 6, 1 by r to the power 6. There we have added our ionic bonds with us. An idea on ionic bond we already have taken. Now let me take you directly to the covalent bond and the coordinate bond. Coordinate bond is also one of the covalent bond, but it's a special type of coordinate covalent bond. Let's see the first question, guys. JEE Main 2024, a question that was asked in JEE Main 2024. The question simply says that the number of sigma and pi bonds are there in ethylene molecule. You all know about the ethylene molecule, and we'll figure it out very soon. Number of sigma and pi. Ethylene is actually nothing but ethene. So carbon is there, one hydrogen, a double bond, a carbon, one hydrogen. This is ethene, C2H4, CnH2n. Please find out the numbers. So number of sigma are 1. So this is actually sigma. So this is sigma, this is pi, sigma and sigma. So 1 sigma, 1 pi. Okay. So 3 and to 5 sigma and 1 pi. I think B is correct. Let's see the another question. The order of covalent bond is what? Covalent bonding we have to talk it about. And now also we will apply Fajan's rule. Here also we have to apply what? Fajan's rule. The order of covalent bond will be what? Kf. Does Kf have more covalent? Order of covalent bond means percentage covalent bond, right? I think this has been asking about which one of them is having higher covalent character. So first is Kf. This is incorrect. Lithium fluoride has higher. This is true. No, the correct answers from the options given below. There Ki is correct. This is also correct. SnCl4 has more because higher is the charge of cation, higher is the covalent character. CuCl, Cu of course, Cu plus has pseudo nut gas configuration. Copper positive has more polarizing power than sodium plus. Lithium fluoride, then Kf, this is true. And lithium, then this smaller is the size of cation, more is the distortion. Copper, then this is incorrect. Then Kf is having lesser. This is correct because higher is the size of an ion, higher is the polarizing ability, and higher will be the distortion, and higher will be the covalent character. And then this is also correct. PIGC, this is pseudo nut gas configuration, this is normal nut gas configuration. Always pseudo nut gas configuration has higher polarizing power of the cation because of its D subshell, which contains electrons, and that's why poor shielding is there, higher Z effective is there, higher extent or higher charge density is there, which can distort the front negatively charged cloud over there. Now look at the correct answers, guys, where you can see all correct answers. The all correct answers are seen on B option, then we had C option, and in E option. So probably some options were given up over there like B, C, E, A, E, D, and like that, and this is what we had to pick. Taking you to the next question, came in JEE in 2020. And statement 1 says that oxygen, Cu2 positive and Fe3 positive are weakly attracted by magnetic field. Something which is weakly attracted by magnetic field is called as paramagnetic species. Something which is weakly repelled by it is called as diamagnetic species, and are magnetized in the same direction of the magnetic field. So this is paramagnetic. Okay, Cu2 plus is paramagnetic, odd electron, iron 26. These all are odd. This statement is true, guys. True. Sodium chloride and water are weakly magnetized in opposite direction to the magnetic field. This is what we call as diamagnetic. And NaCl, benzene, water, these all are diamagnetic and they are weakly repelled by the applied electric field, which is I think also true. Now can I see both of them are true? See statement 1 and 2, both of them are true. A is the correct answer. So lehra do सर खुशी का परचम लहरा दो. Guys, let me announce one very big festival that Unacademy is bringing for all of you. That is of 1st of March, tomorrow by same time, evening 7 p.m. Let me show you, let me take you over there. And this is the event that Unacademy is bringing. This is JEE Nexus by Unacademy. This is JEE Nexus by Unacademy. You just simply search it in JEE Nexus on YouTube. You'll find this thing. It's gonna to be live in just 26 hours on 7 p.m. tomorrow. My pretty request to all of you guys that please go and just do this notification on. Do notify, so that you will be updated. You will be updated for our this the biggest festival of India in education that we are bringing. So I want every one of you to enjoy this. Please join us. Now we can come back to our questions. Okay. So this is the event where not only just this is not only just for us as an educator. Yeah, it is all for all the students who are lively watching us and who will be who are gonna to appear in their 2025, 2026 and even 2027 journey of their IIT, medical or whatever the stream you right now are into. Even the student who are not in the engineering and medical field and they are belonging to some other fields of CLAT, CAT, GATE, whatever it is, pre-UG and pre-PG examination, they all will be revealed with so many big surprises by Unacademy. The top educators will be teaching you in very what must I say, that very nominal fee of the cost of the every single plan that you are going to buy from Unacademy, and lots of students will be getting so many benefits, as in some scholarships will be revealed, and lots of things, some gaming things will be happening over there, some gifts could be provided to you, celebrities will be coming over there, influencers will be over here. So it's a big day for all of us, so we all are equally excited. This is the RMT 2025 happening, and this is like just by tomorrow only. We all be going there to attend it. You will be allowed to join us on YouTube. Visit JEE Nexus by Unacademy. That's it. Now that's it. I will be taking you back to the session. Let's come back to the session. लहरा दो आरंभ का. Anyways, let's come to the question. Both statements are correct. Let's see another question. Arrange these number of compounds in increasing order of their covalent character. So first of all, they all have same cation. It's all about the anion now. So guys, you know, this covalent character is directly proportional to the polarizing ability. Polarizing ability, which is also called as polarizability of anion. So, and this is also directly proportional to the size of an ion. Higher is the size of an ion, higher will be its, I must say, polarizing ability, and higher will be the covalent character. So this works in this way, like fluoride, then chloride, bromide, iodide. This is the order of size actually, and thus this will be the order of the same. Correct answer should be what? Calcium fluoride, calcium chloride, calcium bromide, calcium iodide. This is the order of covalent character. Where is the correct answer, guys? DCBA. DCBA. I think B is the correct option. B is the absolutely correct option. B is correct. Let's have the another question from here. So the covalent alkaline earth metal halide is what? And as I have told you, it follows some certain set of rules over here, that if we go down the group, halides are the same here. So we'll be seeing that apply Fajan's rule over here. If we apply Fajan's rule, then we find that the covalent character is directly proportional to the charge density of cation, means smaller size. So this is called as polarizing power of cation, which is directly proportional to the charge, which I see is the same for all the alkaline earth metal, inversely proportional to the size, and also directly proportional to the pseudo inert gas configuration. But only this factor will be applied over here, size. And we all see that size varies in this way, that beryllium has the smallest size, followed by magnesium 2 positive, followed by calcium 2 positive, followed by strontium 2 positive. This is the order of size. So which one of them will be having the highest polarizing power? This one will be possessing highest polarizing power. The one with highest polarizing power, its compound will be highly covalent in nature. Correct answer must come up as D. Check it out. कौन उत्ते में लुटे कौन लुटा मैं पूरी पावर जाने कुड़ियां देन फ्लावर जाने ते कौन उत्ते मैं डॉलर टूटी थी Hopefully you all have got it rightly. Okay, so now we'll take you to the next question from here. Let's come to the next question, guys. So everybody, we have the next question, and this is your beryllium halide is the correct answer, and that's why the compounds of beryllium are predominantly covalent in nature. Which of the following, a question came in JEE in 2018, which of the following compound contain no covalent bond? Okay, KCl has a K positive Cl negative metal on metal bond. So basically, do you know how the covalent bond is formed? We must think in very simplest way. Even a 10th standard student can do this question, that an ionic bond is usually formed by metal and non-metal. Okay, metal generally possesses a positive charge, non-metal possesses a negative charge. A covalent bond is actually preferred by non-metal and non-metal. Okay, and there's a mutual sharing of electron takes place. There is also one more type of special bond. And this special bond is called as coordinate bond. This coordinate bond, not coordinate, yeah. Coordinate bond is a special covalent bond only. We have metal bond also called as metallic bond, which is actually formed between two metals also. Okay, there also some specific type of electronic distribution takes place. So let's look at this question again. We had K positive and Cl negative with us, which is metal and non-metal. So definitely this is an ionic bond. And I think that is it. That is the correct answer also. But look at other examples also. Does anyone has a covalent bond over here? No, PH3 doesn't have. Oxygen. This is also covalent. This is ionic, covalent, and this is also covalent. Correct answer should be only KCl. D is the correct answer. Anybody can submit the correct answer. This is D. Most easy question as such. Most easy question. Okay. Let's see the another question. We have now valence bond theory. We have completed 2 to 3 important parts of this chapter. Number 1 was the very first of them was okay, allow me a sec. Now let's come back. So where were we? We were discussing about that we have till over here we have completed Koster-Lewis theory, ionic bond, covalent bond. Now this is the another part called as valence bond theory, VBT. And there are like VBT is very important if we talk about covalent like coordination compound, and we also have chemical bonding. Both of the chapter have valence bond theory as a concept, and both of them have equal priority of valence bond theory because in previous few years questions have come from these theories. Okay, so let's look at the question. Question simply says that the lowest oxidation state of an atom in a compound A to B is -2. Okay, then the number of electrons in its valence shell is what? This is a tricky question, by the way. What is it? Lowest oxidation state of an atom. So they are talking about oxide actually, which can accept 2 electrons, can form oxide, and oxygen cannot accept even more electrons because till here it's all orbitals will be filled. We are talking about oxide. So the number of valence electron will be what? So I think 8 should be the correct answer. No, the number of valence electron in valence shell, lowest oxidation state of the atom in a compound A2B is -2, lowest oxidation state of an atom in a compound A2B. I don't know what is it talking about. Let's suppose I'm talking about H2O now. So this is -2 oxidation state, this is +1 oxidation state. So number of electron in valence shell will be, oxide will be having how many electrons? 6 electrons. It already has 2 electrons with more. 8 is the correct answer. 8 electrons. Can I see 8 is the correct answer? Puri power chane, chane. 6 is the correct answer. Actually, the number of electrons in its valence shell. So actually, this is the number of electrons in B it is talking about. But what I have submitted over here is for B2 negative. So let's simply take the example of oxygen. Then your correct answer will be 6. For oxygen, this is 6 here. But actually, this is not clear question to me. If you face the same, let me know, because I found this is something which is not tricky, but it is bit of confusion I face over here. Bit of confusion I see. Let me take you to the next question from here. There we have the next question. Asked in JEE in 2019 that a pair that contains 2 phosphorus in each oxo acid. So you have plenty of compounds over here. First of all, we got to know about these compounds. So this is H3PO2. So let's say first of all I'm having H3PO2. What is H3PO? H3PO4, H3PO3? Okay, got it. H3PO2. It contains one OH and the rest are the hydrogen directly connected like this. Another one is H4P2O5. So H4P2O5. Oxidation state is 10-4. 10-4, 6 by 2, 3. So 3 is not the maximum possible. So there will be a bond of metal there. Like this. So P double bond O, P double bond O. If it is equals to the maximum oxidation state, then there is a metal bond should be there. OH, H, like this could be the bond over there. So we have to identify the pair that contains each of the oxo acid, pH in each one of them. No, this is not right actually. Let me check it, man. So I was thinking it correctly that it is one hydrogen. But again, I told you that this will come from the practice itself, guys. It's not like some random thing. It will come up with the practice itself, and when you will be discussing about, you will be studying about the pair that contains 2 pH bond in each of the oxo acid. So there I think this is correct and this is also correct. I think A is the correct answer in that case. A is the correct answer. A is right. In P block we study about the oxo acids of phosphorus, and there we discuss about all, but I gave you an idea In the initial stages of this chapter, I told you that better you should look out for all these questions. I initially told you about this thing, that you should look out for all the possible oxa acids. लुटे कौन लुटे मैं. Let's see the another question until then. We have the next topic from here called as hybridization and VSEPR theory, which is the most weightage carrying topic for all this chapter. This complete chapter has highest weightage topic, VSEPR. Then we have hybridization, and one more topic is there, molecular orbital theory. So let's see the first question from VSEPR came in 2025. You will find lots of questions from this segment. Molecules having square pyramidal geometry. So where does this square pyramidal geometry comes from? Okay, so first of all, this is actually trigonal bipyramidal geometry and square pyramidal. So mostly the square pyramidal comes from okay, from there it comes, right? Square pyramid. There should be one lone pair. Total stage number comes up as 6, where you can find out of square pyramidal. And there, this is actually your square pyramidal, right? I can do one more thing. Let me write it for all, and then we will go for the correct answer. Okay, let me just take an idea for all, and then I'll go for there. So this is BRFI. So the structure, I can assume this in my mind, as I told you this about the steric number and the correct way of doing these questions. There is one lone pair and rest of them are fluorine. This is how the structure looks like. This is square pyramidal. So let's suppose if I'm just talking about their shape, this is actually square pyramidal. The another one is PCl5. So we all know about PCl5. This is trigonal bipyramidal, and this structure is trigonal bipyramidal. Next is SBF4. Again the same thing, phosphorus, and these all belongs to the same family only, 15th group. Antimony and phosphorus, they all are from the same one. PCl5, they all are trigonal bipyramidal. XeOF4 could be the correct match. XeOF4. Can we check XeOF4? We have XeOF4 structure somehow like this. OF4. Okay. Wait. 4 fluorine in the same plane. One is the oxygen double bond O, and another one is the lone pair. This is also square planar shaped. So now I think enough of the molecules are here with us. Can you pick the correct answer out of it? Out of these, can we pick the correct answer, guys? यार कैसे मैं ले सकता हूँ? So I'll be again taking you to the correct answer from here. This is square planar R. I think these two, BRF5 and XCOF4. C is the correct answer. C is the correct answer. Very good. Another question came in JEE 2025. Seems like this question is not okay. Consider n as the number of lone pair electrons present in the equatorial positions of the most stable structure of ClF3. First of all, let me write ClF3. 7 electrons Cl has, 7 electrons from chlorine, 3 are shared, 4 are the lone, 2 are the lone pairs, 3 plus 2. So this is a T-shaped molecule, looks like this. So the number of lone pair, so number of lone pairs are n is equals to 2 here. So we have to identify which of them has the this much number of unpaired electron. Okay, so this is a tricky question. This is basically a mixed up question with so many other concepts as well. Vanadium has an atomic number 20, scandium, titanium, vanadium 23, scandium, titanium 22, 29, 28, scandium, titanium 22. So let's find out the number of electrons we have over there. This is argon, this is 23, 4s2, 3d3. This will become 4s0 and 3d3, so 3d2. So number of unpaired electrons are 2 here. We have argon 4s0, 3d1. Number of unpaired electron is 1. Then we have copper 2 positive, argon 4s0. It usually be 3d9. So again it will be 3d9. Number of unpaired electron will be. So if we fill it like this, then we'll come to know how many number of unpaired electron can be fit over here. Let's see the number of unpaired electrons. 1, 2, 3, 4, 5, 6, 7, 8 and 9. So number of unpaired electrons are 1. Then we have nickel with also 4s0, 3d8. Now filling the 8 electrons could lead you, fill the 8 electrons, 2, 3, 4, 5, 6, 7, 8. Number of unpaired electrons are 2. So last, titanium 2 positive, argon, scandium, titanium 4s0, 3d2. So this also has, I think, two unpaired electrons are there. Simply I can write it. Now check out the correct options out of these given number of options. I think A is correct. Where else did we get 2 unpaired electrons? D is correct and E is correct. So 3 options are there. So the ions form the following that will be containing these number of unpaired electrons. 2 are A, D and E, ADE. Let's see another question. So there used to be some options over there, but it could not fit in this question. That's why I just have taken only this part of the question, and then we have already got the solution. Another question that was asked in 2025, please read it out and let me know the correct answer. So which of the following statement is true to H2O, NH3 and CH4? That central atom of the molecule are sp3 hybridized, which is true. This bond angles in the above molecules are respectively 104.5 and 7. This is also true. Because we all know their structure. Let me write their structure one by one. Then you will understand how does this structure look like. This is how it look like for oxygen. We have 2 lone pairs. This 2 bond pair. Nitrogen has one lone pair, 3 hydrogen atoms are there. We have carbon, sp3, all of them are sp3, but the bond angle varies in this way, what I have been shown over here. Then the increasing order of dipole moment. The increasing order of dipole moment, I think this is also true. Now, okay, then H2O and NH3 are Lewis acid, while CH4 is Lewis base. Actually, these are Lewis acid, which is a wrong statement, because they have a lone pair with them. They can donate their lone pair. They are not Lewis acid, but in fact they are Lewis base. So this is a false statement. And CH4 neither behaves as Lewis acid nor behaves as Lewis base, because it has a complete octet of carbon containing 8 electrons, doesn't want to gain or lose electrons as such. This is a false statement. Then a solution of ammonia in water is basic, yes, and in this solution NH3 and water act as Lowry Bronsted acid and Bronsted base respectively. So this is how this reaction works. NH3 plus water gives us NH4 plus OH negative. This is working as Lewis base, and this is Lewis acid. Sorry, not Lewis, this is Bronsted. What has happened here? So this one is actually Bronsted, Lowry Bronsted acid. So this is working as an acid, this is working as a base. NH3 are working as Bronsted and base respectively. This is a false statement actually. If we properly basically read it out, this whole statement, this is an incorrect statement that we see. So which statement over there were basically true that we had to tell? So 1, 2, 3, like A, B, C, and that's it. A, B, and C are correct statements. Let's see another question that was also asked in JEE 2025. As I told you, this is the highest weightage topic which we are right now doing, and so many questions have been asked or appeared in this segment. Number of molecules that show linear geometry among the following. Linear geometry. So I'll try to write all the geometries. Please write down all of them with me and try to identify. Sulfur dioxide has a lone pair. Sulfur dioxide has a lone pair, due to which the shape is a bit bent, not linear. Beryllium chloride has a straightforward, very linear structure. So does the carbon dioxide with sp hybridization. So does the nitride ion, like this azide ion, we call it azide ion. This is how azide ion looks like. This is a negative charge and a positive charge over here. Nitrogen dioxide has a single electron here, due to which it does not have a linear geometry. F2O also has two lone pair on oxygen atom, which is a central atom with two fluorine. Bent shape is still here. Xenon difluoride has a linear structure because of the presence of three lone pairs like this. We have nitrogen dioxide with the nitrogen, it has it. Like this. Then we have I3 negative. Okay, this also has a similar structure as I told you, like this, but it is a linear in geometry. Ozone molecule also has this kind of structure, which is not linear. So from here we can check out which of them are linear in shape or which one of them are not. SO2 is not. This is correct. This is correct. This is correct. No, no, no. This is correct. This is correct. This is also correct. Now how many? 1, 2, 3, 4, 5 and 6. I think 6 is the correct answer. 6 is the correct answer, I guess. Next question came in JEE 2024. Match the following question is here. How to basically know about paramagnetic, diamagnetic, tetra, linear, everything NVC. See, we know about I3 minus, just I have a bit second only, I just have mentioned this, that 8 electrons, 4 electrons are shared like this. Then 2 electrons are shared with other 2 iodine, 4 electrons are here, remaining 2 electrons are here. This is linear, so I think this will go and directly match with the linear. Then nitric oxide has odd number of electron. This has 7 plus 8 electrons. This will become odd electronic species, will be paramagnetic in nature. SO2Cl2. SO2Cl2. Charge, I think this will be tetrahedral. Right, and then comes NO2 negative. The remaining one will be the diamagnetic. So how basically I have explained this all. Let me just give you another simply basically justification. SO2Cl2, you can check out this structure. S double bond O, Cl and Cl. This is sp3 hybridized, and that's why its geometry is tetrahedral. Nitric oxide, we have 8 plus 7. 7 plus 8 is 15 electrons are there, which is making it an odd electronic species. We have nitrogen dioxide along with a negative charge. This will be 7 plus 2 times of 8 plus 1. How many electrons can you see over here? 16 plus 8, 24, which is even. So this will become diamagnetic. And then comes your I3 negative, which we have already discussed. Its structure like this with 2 lone pairs and 1 over there. So this is a linear structure. So that's how it gives you. Okay. Options are not here, guys. So whenever the options will be available, we can pick the correct answer out of it. Let's go to the next question from here. Match list 1 with list 2. Sulfur tetrafluoride, bromine trifluoride, bromine trioxide, and ammonium ion. And we got to mention its geometry. So how can we match with them? First of all, this is sulfur. One lone pair is there, 4 bond pair. So this is steric number is 5. If 5 is the steric number, we'll put one lone pair over here in equatorial position, and axial will be occupied by this like this. So SF4, we have BRF3, 3 fluorine are there, 2 lone pair. It will be a T-shaped molecule like this, along with 2 lone pair in the equatorial position. BRO3, how many electrons does bromine contain? 7, with a negative charge. So Br negative will a total of 8 electrons. Then total 8 electrons and Br negative, right? No idea, dude. Okay, sorry, BrO3, no. So 6 electrons there are there. I think 6 have been shared. So one is the lone pair, and one double bond O, one double bond O, and another double bond O. Pyramidal structure is there actually. And then comes ammonium. Is very simple to draw. Ammonium ion. This contains 4 bonds with it with a positive charge, tetrahedral in geometry. So look at their structures or shape of the geometry that we see. This is called as seesaw. This has become T-shaped. This is your pyramidal, trigonal pyramidal. Ammonium ion is tetrahedral. The correct answer will be. Now match them accordingly. SF4, seesaw, BRF3, T-shaped. Why we are calling it bent T-shaped? Because of this repulsion. This will be bent, a bit bent edge, and that's why it becomes bented T-shape. BRO3, bro. This is actually pyramidal. And finally ammonium will become tetrahedral. Total number of species from the following with central atom utilizing sp2 hybridization orbitals for bonding is. So we got to identify where we can find sp2 hybridized. Okay, sp2 hybridization we have to find out. Let's see, we'll do it. JEE 2024, this question was asked in total number of species from the following central atom containing sp2 hybridized orbitals. sp2 we have to find out. So no problem. We can go for each and individually. So ammonia is there. 1 lone pair, 3 bond pair, 4 steric number will be sp3. Sulfur with 1 lone pair, 2 bond pair is sp2. Silicon dioxide is exactly like will be sp, exactly like carbon. We can take it. It is actually, it exists in form of SiO4 negative. It's a huge crystal, but SiO2 is the general formula we use. But now as a molecule, if we treat it, it will be looking like this. As a gaseous molecule we have to consider. Beryllium dichloride, sp, C2H2, sp, C2H4. Steric number per carbon atom is 3, sp2. Then we have BCl3. Steric number is simply 3, sp2. HCHO. HCHO is what? One hydrogen, one double bond O, another one HCHO, sp2. 3 is the steric number, right? Bond pair, sigma bond pair plus lone pair. C6H6 benzene with all hydrogen like this. This all carbon atom are sp2 hybridized only. Where else we can find it? C6H6 BF3 will also definitely be BF3, sp2. C2H4Cl2. I think all the atoms are like all carbon atoms are available with these bonds only. Hydrogen, hydrogen, one carbon, one one hydrogen, and 2Cl could fit anywhere. Okay, this has not been mentioned. So let me fit it like this: 1Cl, 2Cl. That's how it look like. So now, can you identify where we had this sp2 hybridization? Okay, check out, guys. Please check out where you can see sp2 hybridization. So this is sp3, sp2, 1, 2, 3, 4, 5 and 6. So I think 6 is the correct answer. I am checking out that everywhere we go like this, 6's come always as an answer. We always get 6 as the answer. Six always comes as an answer, right? But don't learn it down that always we have to pick 6 as the answer. 6 is given as the correct answer. Let's see the another question, which is a match the column kind of question from same hybridization and all. We have first example as ICL. ICL is what? Linear, I guess, because ICL is simply like this. Simply like this, okay? All of them will be having set of lone pairs like this, but the shape between these two will be this is linear actually. ICL3. ICL is simply like this. ICL3. 3 chlorine are there. And 2 lone pairs will be there. CLF5. CLF5 one lone pair, 5 bond pair. Wait, 5 bond pair, right? This is square pyramid. Then we have IF7, a very simple structure. Pentagonal bipyramidal, linear, T-shaped, and then we have square pyramid. That's it. So that's it. If some option would have been given over here, we could have matched it, and that's what we do. Next is now match list one with the second. All of the molecules are in the same way, asked in JEE 2024. We have plenty of similar kind of question, as you all can see. Plenty of similar kind of questions are here. So let's look at the first question. First of all, ammonia. So this is how ammonia looks like with a lone pair and 3 hydrogen. How I do it? I apply the steric number method. If you want to get comfortable as I am, please visit my previous lecture on chemical bonding part 1 and part 2. In part 1, I have taught you up to VSEPR theory. In part 2, I have taught you the applications of VSEPR theory, hybridization, and the molecular orbital theory, which is also a very strong basically theory that we will be understanding. So most weightage carrying kind of topic is there. So let's see, this is ammonia molecule we have. Then we have BrF3. Bromine has 7 outermost electron, 5 are shared, and 1 will be there as a lone pair. 5 are shared. Then we have PCl5. Then we have CH4. Methane is tetrahedral simply. So now tell me what structure are we having? Okay, so shapes have been asked. Okay, so shapes we have to neglect the lone pair. Then we have to identify the shape. This is not planar. This is a 3-dimensional geometry called as pyramid, trigonal, pyramidal. So this is pyramid, or call it pyramidal. Then we have BrF5, which is called as square pyramidal. This is called as trigonal pyramidal, because there's a triangle and then pyramid is formed, and this is called a square pyramidal. This is actually trigonal bipyramidal, and this is normal tetrahedral. So please match them accordingly. NH3 will be matched with trigonal pyramidal C, BrF5 square pyramidal, PCl5 simply trigonal bipyramidal. No. The first one, okay. This is trigonal bipyramidal. No, this one. And methane will be what? Tetrahedral. So that's how we have to respond it. Okay, thank you, Vedant. Next we have this theory is ended up now. We have bond parameters to discuss about. Okay, some of the questions will be taking from bond parameter. So look at the bond parameters. Let's first move to a question came from JEE in 2025. The question says that given below are two statements. Statement 1 says that experimentally determined, number 1 is, but what? Experimentally determined oxygen-oxygen bond length in O3 are found to be the same, and the bond length in that is O double bond O is lesser than, this is true actually. This has been found true because this ozone molecule exists into this structure like this. This is called as the resonating structure, and that's why we simply say that the major structure resonance hybrid should look like with a double bond character like this. This is the correct actually structure. This is experimental. And what this thing? This is an experimental structure. This is called as resonating hybrid, resonance hybrid. These two are theoretical. These two are theoretical, and they are called as resonating structures. So this statement is true. The strong lone pair repulsion between oxygen atom is solely responsible, like it is alone responsible for the fact that the bond length in ozone is smaller than in double bond, but more than single bond. This is actually incorrect statement. I can see smaller than this is not possible, more than this is not possible. This is oppositely related. This is a false statement. Read it out, guys. Actually, usually we see that double bond is lesser in bond length than a single bond, and single bond are longer than the double bond. So this bond length should come lesser than oxygen single bond, lesser than this, and more than this, more than a double bond. But this statement is false. One is true, another is false. Where can you find one is true, another one is false? C is the correct answer. Up to me, I think C is the best answer. Let's see another question now. Came in JEE in 2024. A question from JEE in 2024. The question is that given below are two statements. One of them is labeled as assertion, another one is reason. It's an assertion reason question, by the way. Assertion says that there is a considerable increase in the covalent radius if we go from nitrogen to phosphorus. However, from arsenic to bismuth, there is only small increase in the covalent radius observed. Let me reread it. Nitrogen to phosphorus is considerable, true, but from arsenic to bismuth, this is probably because of the insertion of the D subshell. So I think this can be considered as true. Then covalent and ionic radii in particular oxidation state. By the way, this is not chemical bonding question, and this is more or less like it seems to me a chemical bonding question. So covalent and ionic radii in particular oxidation state increases down the group. In light of above statement, what do you want to say? Covalent and ionic radii in particular oxidation state increases down the group, which is true. We are following the same oxidation state, is true. But this is not a correct explanation. So this is true, but not a correct explanation. Where can you find it? I think C could be the correct answer again. Let's see what answer has been given here. Sorry. I can see the maximum number of questions are from molecular orbital theory. Majority of the questions are from molecular orbital theory. Fine, then let's move to the next question then. A question came in JEE in 2023. So questions have been segregated on the basis of their types. Okay, the topic name they have been segregated up, and there are lots of topics as I can see, because as an application of VSEPR and hybridization, bond length, bond parameters, they all comes under the same category, and this is what we are right now discussing, bond parameter. So dipole moment will be another topic. This is how we have segregated, and we have plenty of questions. I saw just okay, we have plenty of questions. We'll keep on doing the questions. Okay, we have this given below are two statement. One of them is SO2 and H2O both possess V-shaped. Statement 1 says that SO2 and H2O, do they both possess V shape, because one of them is SO2 looks like this, one lone pair, and another one is water. So I guess this is true. This is a true statement. The bond length, the bond angle of SO2 is lesser than H2O. This is actually false statement, because if you see, where can you find the more amount of repulsion? This is, let's say this is theta 1, so this is theta 2. So you will find, guys, that theta 1 is greater than theta 2, because theta 2 is nearly 109 degree 28 minute because of the sp3 hybridization, and this is nearly to 120 degree because of the sp2 hybridization. So no doubt theta 1 is greater than theta 2, but it is saying that SO2 is lesser. SO2 is lesser. This is a false statement. Now can you see the correct answer? 1 is correct, second is false, C is the correct answer. I am continuously checking that C is coming as the answer. Very frequent answer. C is a very frequent answer. Okay, we'll move a bit faster from here. We have another question that bond dissociation energy is highest for. So actually, because of the interatomic repulsion, because of the interatomic this lone pair repulsion takes place, due to which the order of highest bond energy becomes Cl2 has the highest one, followed by fluorine, followed by bromine, and then I think iodine. Anyways, this has been asked about the bond dissociation energy highest. I think Cl2 will be the correct answer. This is the order of delta H of bond dissociation enthalpy. Let's see the other question. JEE in 2023. For oxygen difluoride molecule, consider the following: number of lone pair, bond angle, so many things have been asked. First of all, let me give you an idea how does this structure look like. So it's sp3 hybridized, so no doubt the bond angle should be near to 109 degree 28 minute, which is like 104 is fine. So this is a true statement. Lone pair are 2, which is a true statement. Oxidation state of oxygen is -2, which is a false statement, because this is more electronegative. If you will see, this will have a delta positive, this will have a delta negative, because fluorine is more electronegative in that way. This is a false statement. The molecule has a bent or V shape. I guess this is a true statement. And then we have molecular geometry is linear. Molecular geometry is linear, which is a false statement. No doubt, if this is V-shaped, then how can it have this linear structure? Okay, so definitely this is the correct answer. I think option number A, B, and D are the correct answer. A, B, and D. A, B, and D. I think B will be the correct option. Let's come to another question asked in JEE 2023. This question is oxygen-oxygen bond length in H2O2 is X, and then oxygen-oxygen bond length in O2F2 is OH. I don't know what is this. Is X then? Okay, shorter or longer? X could be shorter or longer. Okay, and so we'll have to check it, book guys. How can we check it? See, oxygen, hydrogen, and we have oxygen and oxygen, and then fluorine and fluorine. So basically, this is trying to get the electron density like this, and this is acquiring the electron density from hydrogen like this. There's more electron density, there will be more repulsion between these oxygen atoms. I guess this has more oxygen-oxygen bond length. Right? Because the electron density is basically, we all know that there are like two lone pairs are there. These lone pairs have been attracted towards fluorine, and like electron density is getting reduced. It's like I'm thinking in that way, but we have to check it. And then talking about oxygen and hydrogen bond length. So oxygen and hydrogen bond length should be what? Anyways, it's a factual thing. We have to directly check the answer. So in H2O2, oxygen-oxygen bond length in H2O2 is longer. So this is correct actually, what we have picked, it is correct. So X becomes what? Longer. And oppositely, the another is this oxygen-hydrogen bond length in H2O2 is Y than oxygen-fluorine. So oxygen-hydrogen bond length, since it is attracted by this, electron density will be shifted to oxygen. This will be shorter. So longer and shorter should be the correct answer respectively. B is correct. Longer and shorter respectively. Another question, 2021. Sorry. JEE 2021. This question came in JEE 2021. Given below are two statements. One of them is labeled as assertion, another one is labeled as reason. Assertion says that HOH bond angle in water molecule is 104.5, which is actually a true statement. I give you one example by that time, that methane has a perfect sp3 hybridization, due to which its bond angle is 109 degree 28 minute. And then we have NH3, in which one lone pair is there, reduces the bond angle by 100 and makes it to 107.5. and then comes your water with two lone pair, more repulsion is there, the bond angle becomes even shorter. This is 104.5. The reason is the lone pair repulsion of the electron is much higher in the bond pair repulsion, which is also true, and that is why the bond angle is 104.5. So where can we get the correct answer and the true explanation? I think A is correct. A is correct here. Now let's see the another question. Well, this is something different, but I know I have given one of the similar question or one of the similar explanation while I was discussing about this. Okay. The question is that intermolecular potential energy between A, B, C, D are given as this. So A, B, B, C, C, D, D like that. So what do you think? A has the largest photon enthalpy. So how we can measure it? This is interatomic distances, and so what we observe from here is that intermolecular potential energy diagram. See the we can see that if this is internuclear distance and this is the potential energy, so interatomic distance is increasing if we are moving from AA, AB, ACD. Which bond we are finding most bond energies of AB. So let me write it. Two things I'll be writing. First I'll write the bond energy. The bond energy follows this order, that AB has the highest bond energy because this is the most minimum potential energy, means most bond energy. Minimum potential energy, highest the bond energy. Okay. AB. Then we have, because these two are looking like same only at this edge of time, AA, AC, AD. AA, AC, AD. Then bond energy is this, bond length will be opposite to it, hopefully. So AD has the shortest bond length. Actually AD has the longest bond length in this way, and then A and B are has the stiffest, no idea what is the stiffest bond. Stiffest bond means like weaker bond. AA has the largest bond enthalpy. No, AA lies in between somewhere. So I think this is the incorrect statement. This is also incorrect statement. And D is more electronegative than other atoms. D is more electronegative. Even I have no idea of that. AB is, I don't know, man. Let's check it out, man. The correct answer is A. Now, what is the meaning of this term, man? I think strongest, it might be written over there. Okay. Let me see. Well, this is like stiffest, means this is more or less like the stronger one only. Nice, man. Thank you, Nobart. So this stiffest is also recommending to the strongest itself. The correct answer should be A. Let's try another question. Let's try another. That arrange the following bond in average bond energies of the descending order. Actually, I told you about it also, that higher is the electronegativity gap, higher is the bond energy, and lesser is the bond length. So it's like bond energies are directly proportional to the delta of electronegativity. So delta of electronegativity we got to check. We all know about carbon. Carbon has electronegativity. So let me first see something. Carbon flow. This is the correct answer, because see, and there's one more thing that you can see, that bond energy. See, this is actually 2p 2p overlapping. This is 2p 3p overlapping. This is 2p 4p overlapping, and this is 2p 5p overlapping. The correct answer should be D. D is the correct answer. A question came in 2020. Chlorine reacts with hot and concentrated NaOH and produces compound X and Y. And compound X gives a white precipitate with silver and the average bond order between the compound Cl and O in Y will be what? Sir, right now I'm live in the class. Please come and join, sir.
Sir, you are live.
Sir, please, sir.
So we are live on
Unacademy JEE English.
We have ICSC graduate.
Please, sir.
Sir, please come here. Sir, come.
So we have SPS, sir. Nobody requires any introduction over here. Please welcome, sir.
Sir. Hello, sir. So, sir, this is Unacademy JEE English, new initiative of Unacademy to cater to the English audience.
Yes,
and he is all-rounder English educator.
Thank you.
Every branch of chemistry. Sanjay
That's what I do. Great. Hello, sir. Hello.
Hi, sir.
Please, sir, come and join. Ajitullah, sir. Okay, please welcome, sir.
So,
hello, guys. Hello.
So, sir, these are our stalwarts of offline centers.
I know about every one of them.
So, like learners, you should
let everyone know. Yes.
Learners, you should know. He's like Nammi Nagin, sir, academic head of Vijayawada, Unacademy Vijayawada. He is Ajit Lulla. He used to teach on Unacademy Atoms as well, and he handles Indore Center. SPS sir handles Kota Center, and we have got 99.8 plus percentile in all these centers because of the efforts, meticulous planning, and amazing execution from these three. So, sir, any like single sentences, 2-3 lines to our learners, if you can, sir, Mike.
It's all yours, sir. Please.
Sir,
so it's great that you all are with us, and I am absolutely sure that in times to come, or maybe in the April session, if you have not done, say, probably that well in January, all that lacuna would be catered to in April session, and students who are in, say, 11th or will be appearing in 26, they are in very good hands, and I am absolutely sure of your success. Thank you very much.
Yes. Ajit sir, great sir.
So a special message to all those students, those have not performed well in JEE first attempt. So do not get disheartened by the result. JEE second attempt, you have to crack it. Push harder, and sir is with you. I am definitely sure.
I'm always available, guys, to guide you. Not in chemistry, for all the academics, I'm always available over here. Whatever the doubt you have related to your academics and whatever it comes in your way of your success that you want to ask me, whether it is not even related to the academics, I'm always available. And that's why, sir, these days only I keep on bringing these sessions, like how can you go for counseling session, what colleges you can opt at, what ranks, what percentile, and these kind of things are the one that a person who has already traveled the path of IIT can tell you. So like in 2010 I qualified IIT, and these all the you can see the all educators over here, the celebrities of Unacademy that I can say are right now with us. We all are gathered here.
Modesty, sir.
Sir, actually, why can't we just let everyone know why we all are together over here? Let everyone know about this part, right?
Yes, we all are here together for the amazing educational festival that is Aram. Aram is going to be live tomorrow from 7 p.m. to 9 p.m. Go to Unacademy JEE Nexus channel. Click on notify me so that you can get proper notifications, and yes, do remember to watch the entire session. There are a lot of reveals, lot of surprises for you.
Yes, thank you so much, sir. So please, sir.
Yes,
I just want to give a small suggestion, a method to get perfection in any topic. The formula is 4R: R1, R2, R3, R4. R1, read to understand and to memorize. Read everything related to that topic with patience. Understand, memorize. Anywhere you have problem, reach the educator. R2 is revision immediately. Close everything. Take your rough notebook. Whatever you understood, you try to present there. And any difficulty you have, get back to R1 or take help of the educator. R3 is reflect, question solving. Without completing R1, R2, please don't proceed to question solving. Complete R1, R2 properly with patience. Then go for R3, which is reflect. These three will help you getting perfection in the topic, but the biggest challenge you have is you have to remember it till the final examination. So R4 is revision again, right? This will help you to make you better in the content, and test error analysis, which is very, very important. So these two will help you definitely. So keep investing efforts continuously. Law of conservation of energy says efforts are there, definite result also will be there. All the very best, kids.
Thank you, sir. Okay, sir. Please continue.
Thank you so much, sir. Thank you so much for even motivating me here. Now I feel more energy, guys. So let's continue our question from chemical bonding, and allow me a sec. So hopefully, guys, you all are now feeling quite motivated, and as we all have got very good response from the celebrities of Unacademy, the top educators we have over here, we all are have gathered here for joining our very biggest educational festival gonna to happen tomorrow. You all are welcomed over there. Watch it on JEE Nexus, live on JEE Nexus by Unacademy, 7 p.m. Okay, let's come to the question. We have two things over here. So this reaction basically must be known to all of us. This actually will be seen in P block when we'll be dealing with the chemical reactions of the group 17 or chlorine and the group 17 properties, the group 17 elements. So this is, if this is a cold NaOH, it gives you NaCl plus NaOCl, okay. Similarly, if this is hot NaOH with us, then it will give you NaCl plus NaClO3 along with water, right? Along with water. Might not be the balanced reaction, but you can balance it by your own. The important part that we have to check it is it produces a compound X and Y, where X gives a white PPT with silver nitrate solution, and the average bond order between Cl and O in Y is what? Average bond order in Cl and O. So with reacts with hot concentrated and produces this. So this is the reaction right now we are talking about. So this reaction is giving you X and Y. So do you know what this X basically on reaction with Ag and O3 gives you AgCl, which is a white PPT, along with we have white PPT, not just white PPT, we also have NaNO3, which always stays there as an aqueous state, right? And then we also have Y with us. So the average bond order we have to find it Cl and O in Y. So this is what the question is. ClO3 negative, we have to talk it about. So let's see how many number of electron does it have. By the way, 8 electrons are right now over there with 3 this one lone pair will be there, one oxygen like this. The bond order is simply, it's 2, I guess, right? Can I check the correct answer? 1.68 to 1.67. I think something is okay, got it. So this is how the structure of this element, this species look alike. So you can see there's a formula of calculation of the bond order out of the resonating structure. So whenever we deal with this formation of the structures and all, we always think of this in way. I remember one of the theory, Causal-Lewis theory, where I explained it, that whenever a side atom of like oxygen with a negative charge will be the side atom, always being at the side atom, okay. So and a positive charge will be provided to the central atom. So bond order will be a number of bonds upon the positions. So number of bonds are 5, positions is 3, 1.67 is the correct answer. That's how this answer has been taken from here. The answer has been given 1.6 to 1.67. Simply. We have another question, came in 2018. It looks like very big question, by the way. So what is this question about? HNNN, I don't know what is it. Hydrozoic acid we are talking about now, and we got to give the idea about first and second structures. What is it, by the way? Bond in hydrogen azide, HN3 molecule we are talking about. The bond 1 and bond 2, achuk, between the nitrogen only we have to talk about. So this is hydrogen, this is nitrogen, nitrogen, nitrogen. I have to arrange their electrons somehow like this, double bond, double bond. This is positive, this is negative. So what do you think, which of them should be like this? Okay, this can be also written down as triple bond. Like this also it can be shown with a positive charge here and negative charge over here. One of the resonating structure, but I can see that in all the phases I find that this bond length is smaller than this bond length is smaller. This bond length is smaller. So I think let's say this is A, this is B. So no, actually this is first and second only. This is first and this is second. So I guess first is greater than second. I think if this is 2 and all written over here, like that. Oh, first you can see bond order we are asking, or bond, okay, bond order we are asking. This is first bond. So first bond order is actually less than 2, you can see, and this is greater than 2, you can see. So first is less than 2, second is greater than 2. I think A should be the correct answer. Can I see the correct answer here? A is the perfect answer, guys. That was a good question we had. Out of these similar looking questions, we had an amazing question with us. So now I'd like to give it a break for a while. We have to take a break for a while, then we'll continue from there. Let me check where we are having. Well, this seems the last question for the day, then we'll take a break. So the bond angle HXH is greatest in the compound. So let me draw all of them and then I'll let you know. This is basically methane molecule. The theta over here is 109 degree 28 minute. Ammonia, we have the similar structure, but over here we will have 107.5 degree. Then we have water here, one hydrogen, this theta will be 104.5 degree, even lesser because of this repulsion. And then there is something that we study about the Drago's hypothesis. Hopefully you all remember, I told you about. So in Drago's hypothesis, the bond angle even decreases and reaches up to just 92 degree. This is a Drago molecule. Okay, so where can you find the lowest bond, or lowest or maximum, it has been asked. Okay, bond angle of HX is greatest. I think greatest should be in CH4, no doubt, perfectly fine. So that's how we can do it. And we right now are having dipole moment, and then beyond that we'll be solving in upcoming some hours. Until then, guys, I would like to invite you to our very special, very biggest, India's biggest event that we are bringing JEE on this JEE Nexus Unacademy channel. There is the notification button, guys. Please go and click on the notify me button, and where click here. This is our Aramb, most loved and most awaited session and a most awaited fest we are bringing. It's a festival, guys. And until then, we are having a break time with us. We'll be having break. And please don't forget to like the session. So do it. अरे यार, So that was some healthy break we had, guys. Now we'll continue and we'll start it. Okay, I'm audible. Thank you. Well, everybody of you will be getting some good news on ARM. So so guys, please take out your books and let's start. Where we left our session. So I remember we left it over here. Up to like till here we have solved all the problems. Now we'll start it from dipole moment. Okay. Let's start it from dipole moment. So arrange the following compound in increasing order of their dipole moment. So there we have a set of molecules with us, and these molecules are very random molecules, but anyways we will come across every one of them. So this is HBr, partial plus partial negative, and let me also write the delta of En. Only one bond moment is over here. Delta n is like this is this has an 2.1 and this is 2.6 or 2.7, or let's say 2.8. 0.7 is the electronegativity gap. Then we have H2S. So this is having in this direction, this is the dipole moment in this direction, these two are also the dipole moments in these directions. So there will be a mu net is into this direction, right? Delta of electronegativity will be, hydrogen is 2.1, sulfur is around 2.4, so it's like 0.3. So guys, then we have hydrogen sulfide is here, NF3 is also here, NF3. The direction of dipole moment is into this, and this will be having this. This is the most, basically we can say, as you all can see, the discrete dipole moment is there, and this is the lowest dipole moment will be there. Mu will be the lowest over here. And one more thing is there, CHCl3 probably is the having high. Actually it's an experimental data, I can't explain too much about it. It's more or less like an experimental data, so we must rely on the first point. Let's take first point as a final answer, move forward. Sorry. So NF3 has the lowest, as I told you, NF3 is the lowest and CH is the highest. C is the correct answer. In order to that, C will be the perfect answer. Let's see the next question. JEE Main 2024. The number of compound that with zero dipole moment. Zero dipole moment. Where can you see zero dipole moment? HF, which is that mu is non-zero. H2, mu is 0. Mu is non-zero. Mu is 0. Mu is non-zero. Mu is 0. Mu is 0. Mu is non-zero. Mu is 0, non-zero and 0. Now look at all of these and try to give the correct answer. Look at these options and find out the correct answer. How many are there with zero dipole moment? So 1, 2, 3, 4, 5 and 6 are the correct answer. Usually I've seen like whenever these kind of questions come, 6 always comes as an answer. 6 always comes as an answer from chemical bonding specifically. Another question from JEE 2024. Given below are two statements. One of them is labeled as assertion A, another one is labeled as reason R. Assertion says that NH3 and NF3 molecules have pyramidal shape and with a lone pair of electrons on nitrogen atom. The resultant dipole moment of NH3 is greater than NF3. NH3 molecules pyramidal shape, but the resultant dipole moment of NH3 is greater. This is true statement. This is saying that mu of NH3 is greater than mu of NF3. Just true. Next is that in ammonia, the orbital dipole due to lone pair. In ammonia, the dipole moment is due to the lone pair in the same direction, which is true. And NH bond and F is the most electronegative. In NH3, the dipole is due to the same direction of the NH bonds. F is the most electronegativity element. I think this is true and a correct explanation also. This is correct explanation also, D. Because the dipole moment of ammonia is actually higher than NF3 because all the nitrogen hydrogen bond moments are in the same direction, and they are not in same direction but they are pointing towards one direction. They are converging, they are not diverging like NF3. Number of compound species which will be forming a non-zero dipole moment is exactly the similar question, came in 2024. Hopefully the answer doesn't go 6 over here. Non-zero, so this has a mu of 0 linear geometry, mu is 0 uniform geometry, mu is non-zero. XeF4 has this kind of geometry with the two lone pair up and down, mu is 0. CCl4 has mu 0, non-zero, 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 0, 0, non-zero. So where can we get the correct answer? With non-zero dipole moment are 1, 2, 3, 4, 5. I think now 5 is the correct answer. Five is the correct answer, guys. Another question from JEE 2024. Which one of the following molecule has the highest or the maximum dipole moment? So we need to check the maximum dipole moment. We have zero dipole moment over here. We have non-zero dipole moment over here. Non-zero over here. And this is 0 also, PFI. Correct? So definitely there is a competition in these two, and we know that NH3 has higher dipole moment than NF3. The correct answer will be, no doubt, C, with the best explanation you had. Okay. Another question. So since fluorine is more electronegative than nitrogen, the net dipole moment of NH3 is greater than this, which is a false statement. Man, so many questions were on NH3 and NF3. So many questions from NH3 and NF3 came actually. This is a false statement. Next question is, next statement says that in NH3 the orbital dipole due to lone pair and NH bonds are in opposite direction. This is also false. They are in same direction, and that is why. That's why they have higher, NH3 has higher dipole moment than NF3. So both statement can be false. Is it possible? Both statements are false. I think C could be the correct answer. Next question came in JEE 2024. Total number of molecules with zero dipole moment are. Total number of molecules with zero dipole moment. Mu is 0, 0, non-zero, 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 0, non-zero. The question is, how do I know about these molecules that frequently? Because I have worked on these, I know the structures of each and individual one, and that is the application of VACPR and the other theory we discuss about VACPR and hybridization. It's all the application of that only. Okay, the correct answer is with zero dipole moment. With zero are 1, 2 and 3. Three is the correct answer. Next, let's see the another question now. That a diatomic molecule has a dipole moment of 1.2 dBi. If the bond distance is 1 angstrom, then fractional charge on each atom is what? For the very first time, I see these kind of questions, numerical questions from on dipole moment. I'm seeing it for the very first time. So the question is simple and says that diatomic molecule dipole moment is this. If the bond distance is 1 angstrom, fractional charge is what? So this is like mu is equals to Q multiplied by D. Mu is 1.2 dBi, and in dBi we also write it 10 to the minus 18 ESU centimeter. Charge must be taken in ESU. Distance is already given to us is 1 angstrom, will be 10 to the power minus 8 centimeter. It could have been minus 10 meter, but we are taking it in centimeter. Okay. So now 1.2 10 to the power minus 18 and 10 to the power minus 8 centimeter. So 10 to the power minus 10 fractional charge on each atom will be what? 1.2 into 10 to the power minus 18 ESU into centimeter. Then charge will come in ESU. Distance is I don't know, there is some error in the calculation or what. How are we getting this data? Fractional charge on each atom is 0. Fractional charge is 0. If diatomic molecule, dipole moment is 1.2 D. Fractional charge is... Let me check it. So let's go back to the question. What was diatomic molecule 0 dipole moment? Okay, let me check it because it doesn't show me. Now I got it. How is it done? So guys, actually this is not correctly mentioned here, and you know what, I can't take this thing as a charge because this is mu experimental. This is mu experimental. So we have to find out mu calculated first of all. So let us suppose these two are a diatomic molecule is there, A and B, acquiring, let's say, plus E and minus E charges. Let's say plus E and minus E charges be there. So we have mu calculated here as how much is the charge? 60 to the power minus 90. Distance is given to us, charge we have to find out. So guys, actually this charge is 1.6 10 to the power minus 19 coulomb, and coulomb to ESU is 3 into 10 to the power 9. So just divide it by 3 into 10 to the power 9. Sorry, multiply it 3 into 10 to the power 9. Then this will become a charge of electron in 4.8 10 to the power minus 10 ESU will be the charge. So that is what we needed. Now I got it completely. I've got this question completely. So how are we gonna to proceed with this question? Let me see. Okay, there we go. So mu calculated will be so the bond distance is 1 angstrom, then fractional charge on each atom is what? Calculated will be what? Q multiplied by distance. Q is something which we have got 4.8 10 to the power minus 10. Distance is 1.2 10 to the power minus 8 centimeter. This is ESU. So this will be coming up as what is this 1.2, man? This is just 1. Okay, so this will be 4.8 10 to the power minus 18. It's 4.8 10 to the power minus 18 ESU centimeter. So fractional charge will be mu experimental upon mu theoretical. So we have assumed it proper charge of 1e 2e, but the charge is not proper charge, it is somewhat lesser than that. So how much is it? So that we can find out using this on one atom. Experimental upon theoretical. Experimental we have got it 1.2 divide, theoretical 1.8, fractional charge will be 1.5. This is 0.25. This can be written as 2.5 10 to the power minus 1. Correct answer will be 2.5. Check out, guys. Correct answer is 0. No, it's 2.5. So that's how we have to approach the question. Now let's see another question. Choose the polar molecule out of following. We got to pick the polar molecule out of following. Choose the polar molecule out of following. That CCl4 is no polar, CH2 is no polar, CHCl3 is fine. It's very simple, guys. CHCl3, the bond moments will not be adjusted and not even in equal magnitude. So all the dipole moments are there, non-zero. D is correct. Consider the following statements. NF3 molecule is a trigonal planar. False. It's not planar, it's pyramidal. Bond length of N2 is shorter than O2. Bond length of nitrogen is shorter. This is true because nitrogen has a triple bond while oxygen has a double bond. Triple bonds are shorter and with more bond energy than double bond. Dipole moment of H2S is higher. Dipole moment of hydrogen sulfide is higher than that of water, which is a false statement again, because oxygen is more electronegative. Oxygen being more electronegative than sulfur, the dipole moment should be higher for H2O. Isoelectronic molecules, isoelectronic ions have same bond order. Isoelectronic molecules can have identical bond order. Let me check. N2 usually has same bond order. CO same bond order. I think this is right. Another statement which is right. But have you ever observed, by the way, what has been asked? Consider the following statement. Which of the following statement are correct actually? Okay. So I found one of them is correct. B and C could be the correct answer, I guess. No, B and C. This is true then. So I think B and C. C is the correct option. Then we have JEE 2023. Statement 1. Dipole moment is a vector quantity and by convention is depicted by a small arrow with tail and negative center head pointed toward the positive center. Dipole moment is a vector quantity depicted by small arrow on tail on the negative. This is wrong. The dipole moment head is towards the more electronegative, tail is towards the less electronegative. This is del positive, del negative. False statement. The crossed arrow of dipole moment symbolizes the direction of the shift of the charges. Crossed arrow. No idea as such, but yeah, this arrow is actually representing the shift of the electron from positive to negative. This could be true. I have no surety on this, but let me check the correct answer. Statement 1 is incorrect, but second is correct. I think B is true. That's how we do this question. Next is, list the following dipole moment. Charge into distance is dipole moment. Psi of molecular orbital is psi a minus psi b. So which is having anti-bonding molecular orbital. Psi a plus psi b is bonding molecular orbital, and this is called as bond order, number of electrons in bonding minus anti-bonding by 2. So the correct answer should be A3, B1, C4. I think C is correct answer. So that was the question from JEE 2022. This is an absolutely correct answer. So among the following, the number of molecules having net resultant dipole moment is, I don't know what is this question about. Among the following, the number of molecules net dipole moment is. So they will be having net dipole moment, means there is mu net which will be non-zero over there. It will be non-zero. So these are NF3, BF3, BF2, CaCl3, H2S, these like. So guys, NF3, mu is non-zero, mu is 0, 0, non-zero, non-zero, 0, 0, 0. Now check out where we have non-zero dipole moment are 1, 2, 3. With some net dipole moment, we have 3 molecules. Let's try another question. Among BF2, these number of molecules with non-zero. Similar questions have been asked, man. I'm tired of these now. This is mu 0, 0, non-zero, non-zero, 0, non-zero. How many molecules are with non-zero? So 1, 2 and 3. Again 3 is the correct answer. 3, 6. These are very common numbers in these questions. That was it. Now another application. We have resonance now. Okay. So we all have heard of this term resonance. Not too much of questions come out of this topic from inorganic chemistry, but yes, it's very important topic from organic chemistry and GOC specifically. In the difference in the energy between the actual structure and the lowest energy is called as the resonance energy. Simple statement based question. Identify the species with 1 pi bond and maximum number of canonical forms. 1 pi bond, just 1 pi bond, and a maximum number of canonical forms in following. So 1 pi bond should be there and maximum canonical structure should be there. I'm not getting it, man. But none of them has in this way. Probably D could be the answer. I think D is the correct answer. Why? Because carbonate has 1 pi electron, yeah, 1 pi bond. Also it has 3 resonating structures. So let's come to the next question then. Van der Waals forces. Oh man, so many questions have come from this topic. Relative strength of the relative strength of inter-ionic or intermolecular force. In decreasing order. Okay, so ion force is actually dominant over ion dipole, and then comes dipole dipole. It's very easy question, by the way, but majorly of this concern we basically think we take this thing in account in especially in the gaseous state chapter. Gaseous state chapter we discuss about the type of these intermolecular forces working between the gases molecule. Okay, hydrolysis, what is this? So among the following halide, which one are inert to hydrolysis? Inert to hydrolysis will be one which is having no unpaired electron, or which is no vacant orbital. Which one will be having no vacant orbital where water molecule can go and donate the electron pair? So A could be the correct answer. One actually, that's it. Hydrogen bonding questions are here. Number of molecule that which will be exhibiting hydrogen bonding are CS3 was true, no, yes, yes. So how many can you say? 5. Yeah, 5 is correct. Next, considering the following reaction, nickel sulfide reacting with NiNO3HCl, some product will be there. This A reacts with this and forming B. Then number of protons that do not involve in hydrogen bonding of the product B do not involve. Actually, this product is NiDMG whole twice. This is the product which we are getting. Let me write you the correct structure of this compound, but this is not from chemical bonding. This is a question. Actually, inorganic chemistry is vast, and there are some concepts which are interlinked to each other. This is a question from coordination compound, and not just coordination compound, quality analysis. So where we understand this thing. So DMG, this is dimethyl glyoxime. Let me see its structure once. C double bond NOH. There's an H bonding over here. Another H bonding. So it is asking us that how many number of hydrogen are there which are not involved in H bonding. So what do you think? I think this is CH. I think 4 hydrogen atoms are not in hydrogen bonding. Dimethyl, I forgot to write dimethyl, man. Sorry, my bad. This is not hydrogen, this is CS3, man. I forgot it, man. Its name is DMG, dimethyl glyoximate. So now you can check out how many hydrogen atoms can you see. How many hydrogen atoms can you see, by the way? 3, 3, 3, 3. Now the answer should be 12. 12 hydrogen atoms are there. Now we'll see another question. Oh, great. Oh, great. So now we'll see the another question, guys, from here. 12 is the correct answer in this. Another question from H bonding, that hydrogen bonding exists when hydrogen is covalently bonded to very highly electronegative atom, which is true. Intermolecular H bonding is present in orthonitrophenol. Actually, it is intra bonding is there, intramolecular, because if we are talking, this is a false statement. Okay, why am I calling it a false statement? Let us look at the example. This is nitro group and this is a hydroxyl group, and this kind of H bonding is called as intramolecular, not intermolecular. Next is the magnitude of hydrogen bonding depends only on the physical state of compound. The magnitude of hydrogen bonding depends on the physical state of the compound. No idea as such. H bonding has powerful effect on the structure and properties of compound. Structure and properties, true. So how many of them are correct? So where can you see A and E? Correct. A and E are only over here, so that's why C, a D statement, is also true. AD is the correct answer. So that's how I figure out the correct answers using the option elimination process. Another question from JEE in 2024. Given below are two statements, one of them is labeled as assertion, another one is labeled as reason. PH3 has lower boiling point than NH3. False. No, true. NH3 has a higher boiling point. Then liquid NH3 molecules are associated with van der Waals forces, but PH3 associated through. This is false. This is oppositely working. NH3 has H bonding and PH3 has just van der Waals force of attraction. So A is correct, B is incorrect. A is correct, B is incorrect, C option is correct. Select the compound of the following which will show intramolecular H bonding. So this will show intramolecular H bonding. A. In ice crystal, each water molecule is bonded to how many neighboring? Wow, yeah. So oxygen has one hydrogen. One hydrogen makes one hydrogen bonding. Two oxygen make two oxygen. One oxygen make two lone pairs with two hydrogen bonding. So this is the answer is 4. Let's see another question. Decreasing order of the hydrogen bonding in following forms of water is correctly represented by decreasing order of the H bonding. Liquid ice, impure water. Impure water will have the least, C. Then in liquid water, A. And then B, ice will have the highest, CAB, CAB. Correct order of intramolecular H bonding strength is, so methane has no H bonding, NH3 will have the highest, and then HCN will be the correct answer. Number of hydrogen bonded molecules associated with this, I think 4 are coordinated, one of them is hydrogen bonded. Actually this molecular structure is a bit different, so you should understand in this way that Cu 2 plus 1 sulfate ion Cu H2O whole 4 and then COSO4 dot H2. This is how the formula works. So this is the water molecule which is hydrogen bonded. This is not a part of this chapter. Actually this is a question from coordination compound, and we'll be dealing in coordination compound very accurately over there. Right? 1 is correct. Two statements are there. Statement 1, assertion 1 says that dipole-dipole interactions are the only non-covalent interactions resulting in the hydrogen bond formation. True. Fluorine is most electronegative, and hydrogen in HF are symmetrical. Fluorine is the most electronegative element, and hydrogen bonds in HF are symmetrical. True. I think there is nowhere is the correct explanation, but this is a 1:2, B is false. Oh, dipole-dipole interactions are the only non-covalent interactions resulting in hydrogen bond formation. Non-covalent. No. This is also covalent. This is not non-covalent. False. Actually, this is covalent only. No, this is incorrect. I thought this is saying about covalent character, but this is not covalent. Actually, non-covalent is incorrect. Hydrogen bonding is also one of the special type of dipole-dipole interaction, which is a covalent interaction. Next, see the potential energy for H2 molecule. How is it represented? This is the correct answer. At which it is getting minimum, there happens the bond formation. This amount of energy is called as bond energy. HF has the highest boiling point among the hydrogen halide because it has what? Does it have lowest dissociation enthalpy? HF has highest boiling point among HX. Why? Strongest hydrogen bonding? Yes. Intramolecular strong hydrogen bonding. Intramolecular interaction is independent of the inverse of the cube of the distance of the following is what? Okay, inverse of the cube, I think it should be hydrogen bond because one of the special type of dipole-dipole interaction. Then we have molecular orbital theory, and we'll start molecular orbital theory very soon. We have plenty of questions to be solved upon molecular orbital theory. Allow me a second. So we'll start molecular orbital theory, the final topic of the day, and right after this we'll be finishing up this whole session. We'll be winding up this whole session, but this is a huge topic, requires lots of things over here. Let's start it. The very first thing is, which of the following linear combination of the atomic orbitals will lead you to the formation of molecular orbitals in homonuclear diatomic molecules? So we have px and px. Yeah, px and px. Internuclear axis is z. So px will form a pi bond. S and px and s will give you a zero overlapping. 3d xy, x square y square, no overlapping. This is like 4 orbitals along the axis, and no. 2s and 2px, 2pz and dx square y square, no overlap, perpendicular to each other. So what do you think? I think A is the correct answer only. So if A is there, there is one option, A and B. So 2s and 2px can also undergo overlapping. This is S actually, and this is the orbital that we are about to get it react with. D only. How come, man? Actually, I'm not easily understanding the written over there is what, because if I can understand what is written over there, then I would have made it easily. Actually, what we see is, let me try it from my PPT. Actually, it is not visible to me, and that's why we couldn't reach to the final answer easily. Let me check it first of all from what is the exact question given to me. Actually, it's not readable over there in the board which axis has been mentioned, and that's why I committed the incorrect answer there. Yes, got it. So one option is Z and X. Guys, of course, man, this is 2pz given. That is why I marked it yes by thinking 2px and Z. Now one is Z, another one is X. Zero overlapping. And that's why I'm saying that this is 2s and this is 2pz. So Z, 2pz and X. This is S. This is 2pz. This could be plus and minus also. So this is bonding molecular orbital. This is how we can make it, okay? This could be negative overlapping also. This is constructive interference. This is bonding molecular orbital. This is destructive interference. So we will be getting anti-bonding molecular orbital with a lobe over there as a node. Sorry, with a node over there, anti-bonding molecular orbital. So the correct answer should be only D. So if you can read it properly, then you can answer it properly. It was like that. Next question, total number of molecule to form will be paramagnetic. So according to molecular orbital theory, anything that has number of odd number, see, it's very common that anything which has odd electrons will definitely be paramagnetic or magnetic. So wherever there are even electrons, that will be diamagnetic. So total number of molecules and the species, that will be paramagnetic. So this is actually paramagnetic. This is paramagnetic. This is 16 plus 1, 17. Paramagnetic. This is odd number paramagnetic. Odd number paramagnetic. This is diamagnetic. Then this is Ni2 positive is there. And actually this is from coordination compound, but this will be paramagnetic because it has unpaired electron. And this will be diamagnetic. Again diamagnetic. So can you see 3, 3, 6 should be the correct answer everywhere. we reach to these questions. 6 is the always correct answer. So this is a combination of chemical bonding and coordination compounds. This is a combination of both of the chapters. Next is the number of molecules having bond order 2 from the following molecule. Number of molecules having bond order 2 from the following molecule. Bond order 2. So this is number of electrons in bonding minus anti-bonding by 2. You can also write the electrons and can find it out. But I have a strategy. I have a technique. Find out the number of electrons first. This is 12, 16, 8, 6, 20, 14, 4. Now look at the bond order, guys. The bond order in neon 20 will be 0. Carbon, see 14 is the maximum, that is 3. So anywhere you are moving 1 or 2 electrons, by each electron it will be reduced by 0.5. So in 12 it will be bond order of 2. It is also a bond order of 2. Hydrogen, helium, lithium, beryllium 0. Then lithium, second one is 2, second one is 1, and in helium 0. Now can you find correct answer where you are getting 2 bond order? So I think 2 is the correct answer. 2 species. Which species are having C2 and O2? Psi A and Psi B are the wave functions of atomic orbital. Then sigma star is represented by. If Psi A and Psi B are the wave functions, then sigma star will be of what? Psi A plus Psi B, simple Psi A plus Psi B, not 2 Psi B. 1 orbital, each atomic orbital are about to, what is it? Oh sorry man, sigma star is anti-bonding molecular orbital. I made a bonding, this is anti-bonding, A minus B. Number of molecule species from the following having 1 unpaired electron is 1 unpaired electron must be there. So we can do one thing, we can identify the odd number of electrons over there, and then we will be definitely having 1 unpaired electron. So this has 2 unpaired electron. O2 minus has 1 unpaired electron. It has 1 unpaired electron. Count the total number of electron first. See, 16, 17. Then nitrogen, this is 15. And this is 14. No, 6. 14 only. And this one also has 18 electrons. But out of these all, can you identify how many number of electrons are there in the given species? I think O2 negative is the one. What do we think? So we have 2 species as such, which might be having, I can totally see these 2 species are there which are carrying odd number of electrons. So definitely there will be 1 unpaired electron over there each. Fine. Now please try the next question by your own. This is a similar kind of question. Okay, and allow me a moment. So guys, this is my final session now. So whatever it is left now, we'll cover that part up and then we'll wind up the session. So this is JEE Main 2024. A question came in JEE Main 2024. The question is pretty simple and similar. Nitrogen, the total number of basically species which are having one unpaired electron. So I have told this earlier, right? Or similar kind of question is here. So anyway, just count the total number of electrons, which is 14, 16. So if there is one unpaired electron, then definitely there should be odd electrons. Total electrons should be odd as per molecular orbital theory. This is how much? C2 13. This is one example. 17 one example. This is 18 not as such. Hydrogen 1. This is one example. Cyanide 6 plus 7. 13 plus 1 14. No, this is not. And He positive hydrogen helium 3 electron. This is one example. So I think now here we have 4 such species which can have one unpaired electron. See how easily I have found it. And this is my basically hack that I use, right guys? Anybody who doesn't know anything, who faces any doubt, please let me know. I'll provide. Right guys? Anybody who... Okay, moving forward. Why is it so hot inside here, yaar? Mere gunahon mein. Then we have next question, the total number of electrons present in pi star molecular orbital of oxygen, oxygen plus and O2 negative is or are what? How many number of electrons can we see in pi star or anti-bonding molecular orbital? Pi star is nothing but the anti-bonding molecular orbitals. How to identify that? So we have oxygen. So we have KK-1, KK-2, KK-1, KK-N, sigma 1 is to sigma star 1 is to sigma 2 is to sigma star 2 is to. Now, for this 16 electrons, I would go for sigma 2pz2 pi star. They are asking, okay? Sigma 2pz2 pi 2px pi 2py pi star 2px pi star 2py sigma 2pz sigma star 2pz. This is the order that we have to follow. Now 4 electrons we have filled up to here. Sigma 1 is 2, sigma star 1 is 2, 4, 4, 8, 8 to 10, 10 and then 10 and till here 14 we have filled 14. Then we have 1 and 1 here 16. Now because these are equally energetic degenerated orbitals are here, and this will be having 0, 2p0. So how many unpaired electrons can we see, or how many number of pi star electrons can we see in oxygen? We see 2. Let's come to O2 positive. So in O2 positive we have 15 electrons. The similar configuration will be followed up to here. Only this will be like 1 electron will be here in pi star 2px1, then pi star 2py0, sigma star 2pz 0 with O2 negative. So how many electrons are there? 1. And in O2 2 minus will be how many? So O2 2 minus, which is having 18, sorry, not 2 minus, simply O2 minus. So it has 17 electrons. Similar configuration, similar configuration, similar configuration up to here. Then pi star 2px. Well, lower orbitals have to be filled first. 2 pi star 2py1 sigma 2pz 0. So I think this will be having 3. So 3 plus 2 plus 1, 6 should be the correct answer. Can I see the answer? 6 is correct. जैसे हो कोई मेरे गुनाहों में, मेरे सवालों में कोई. JEE 2024 question is on MOT, molecular orbital theory, that number of molecular orbital that we can form from 2s and 2p orbital. as a diamolecular. So one of them will be bonding molecular orbital, one of them will be anti-bonding molecular orbital. So how many can you form? 2. Arey, shut up. 2s and 2p are how many? So 2s and 2p. So guys, sigma 2s, sigma star 2s. Then we have pi 2px, pi 2py, sigma 2pz. How many number of molecular orbitals can formed from 2s and 2p orbitals of a diatomic molecule? So first of all, there are 4 orbitals as such, right? So this is 2s, one orbital is there, and 2px, 2py, 2pz. So this is how 4 orbitals are there. So out of these, if we mix them, there will be 4 bonding molecular orbital and 4 anti-bonding molecular orbital. There will be like 8 total orbitals. This is one way to solve up with. The another way of solving this could be this. How? So S is there. So while writing the electronic configuration, we have sigma 2s, sigma star 2s, pi 2px is equals to pi 2py, sigma 2pz. Then we have pi star 2px is equals to pi star 2py, and then sigma star 2pz. Now how many number of orbitals can you see? 8 molecular orbitals. We have 8 molecular orbitals. Correct answer should be what? 8. Let's see the another question. Total number of anti-bonding molecular orbital formed from 2. Here we've done it or not? Okay, no. It is asking total number of anti-bonding. So out of 2p, these are 8 MOs, out of which 4 are bonding molecular orbitals and 4 are anti-bonding molecular orbitals. The correct answer should be 4, I guess now. If it is not correct, then it is my fault. Fine now. मेरे गुनाहों में, मेरे सवालों में शामिल तू. Chalo, we'll see the next question now. So it's the question says that the number of species from the following which are paramagnetic and with the bond order equals to 1. So they should be paramagnetic along with the bond order 1. Okay, we'll see. Only 2 species I remember. No. Paramagnetic also should be there. B2 is one. How many electrons does B2 contain, man? 10. Number of paramagnetic also should be there. Sigma 1s2, sigma star 1s2. This is also, but this is or bond order is equal to 1. This doesn't have bond order equals to 1. Helium plus. One is correct answer. I was also thinking that we don't have any as such other where we can fill it like this, because this has pi 2px1 is equals to pi 2py1. So that's why it is bond order is also 1 and number of unpaired electrons are 2. मेरे गुनाहों में, मेरे सवालों में शामिल तू. Next question from JEE 2024. The linear combination of atomic orbitals to form the molecular orbital takes place only when the combination atomic orbitals have same energy. True. Have minimum overlap? No, it should be a greater overlap. Have same symmetry about the molecular axis. It's true. Different symmetry. False. Choose the correct options now. What do you think? A and C? A and C is right, guys. Okay. Sum of the bond order of CO and NO positive. We all are aware CO 14 electrons. Bond order is 3. Bond order is 3. Answer should be 6. I don't know why are they so much like fascinated about this number 6, because we have seen plenty of questions till now which are having 6 as an answer. 6 answer has been like seen over there. Let's see another question. That statement 1 says that a pi bonding molecular orbital, has lower electron density above and below to the electron internuclear axis. So a pi has lower electron density above and below. It's false actually. It has electron density above and below only. Like this is one we are matching up with. So this is how it look like. Plus and minus. So this is above and below to the axis only. This is the axis INA, internuclear axis. Next is the pi star antibonding molecular orbital has node between nuclei. The pi star antibonding molecular orbital has a node between nuclei. Always this is true. It is followed always. Always it has a nodal plane or the node between two nuclei. What do you think? One is true, another one is false. What do you think? No, both of them are. No, one is false, another is true. False and true. D. The bond order of and the magnetic properties of acetylide ion. Oh man, what is that by the way? Same as that of what? Bond order acetylide. मेरे गुनाहों में मेरे सवालों में शामिल तू I think this is C22 minus. Okay. Acetylide ion is what? Acetylene CH2 double bond CH2. No, acetylene is CH triple bond CH. You remove two hydrogen H positive, it becomes C triple bond C. This is the ion. So C2 2 negative ion has 14 electrons, which is matching with NO positive. Another question, but we have plenty of questions on this alone topic. Which of the following processes the bond order increases and paramagnetic character changes to dia? Well, para can change to dia if we are adding 2 electrons. So this is true actually. And bond order increases. No, this is not increasing. Bond order is actually 2 and over here it is 1. Bond order, and this is paramagnetic, this is diamagnetic. This is diamagnetic, this is paramagnetic. The bond order see either diamagnetic, paramagnetic, and the bond order, let us write it nicely and cleanly. So this bond order, first of all, I'm writing, or magnetic behavior I should write. This is diamagnetic, this is paramagnetic. Then N2 is diamagnetic, this is paramagnetic. This is again paramagnetic to diamagnetic. And nitric oxide is paramagnetic, this is diamagnetic. This is correct answer also because I have decoded it from my personal knowledge. This is para, this is also para. So now let me write their bond order also. It is also asking that bond order increases. So increases from where to where? This is 2 and this is 2, this is 1. This has a bond order of 3. This has 2.5. The bond order of nitric oxide is 2.5. NaNO plus is 3. This is correct answer. This is 2, and this one is 1. This is also increasing, but this is not following the order. This is actually 2.5. This is increasing, but the problem is with the diamagnetic and paramagnetic behavior. This is actually diamagnetic. No, yaar, para only. Para to para they are going. So correct answer should be C. So you also try the question along with me, and because it's a time-taking chapter, and we also are, and even I'm facing a little bit of tired now. But how can I leave this chapter here? We have to make this chapter end up. I have to end this chapter properly. Let's see the next question. What is the number of unpaired electrons in N2? N2 positive. Okay, I'll tell you. N2 number of unpaired electron here is 0. It will be 1. It's 2. It's 1. 0, 1 to 1. C is the correct answer. मेरे गुनाहों में मेरे सवालों में मेरे गुनाहों में न कुछ The exam cat is watching me. Nice, man, nice. No, man, it's not like that. Actually, it's been a whole 5-6 hours we have spent here, and that is what it has made me a bit of exhausted, but not a problem, guys. I remember my college days. I used to run, I used to walk, I used to play cricket whole day when we used to play test matches by that time. I remember. So we used to have whole one day sessions of test matches. Not a big deal to me. Okay, you stay quite energetic and respond me over the questions. That will keep me alive. Let's see, the another question came in JEE in 2023. The magnetic behavior of lithium oxide, sodium peroxide, and this is your superoxide, right? Respectively are. So this is actually oxide O2 minus. So this is no doubt diamagnetic. This is O2 2 minus. O2 2 minus is per para. This is actually what is it? Yeah, peroxide. So peroxide is actually diamagnetic again, completely filled. But O2 is actually para. Always remember, dioxygen is paramagnetic because there we have two electrons are filling in pi 2p x1 pi star 2p y1, pi star 2p x1, pi star 2p y1. Because of that, there are two electrons which are unpaired over there, making this O2 as paramagnetic. But coming to O2 2 minus, two extra electron added to the star 2p x and pi star 2p y, two electrons will be filled each, and none of the electron will be over there as a unpaired, and that is what it makes it diamagnetic. Talking to O2 negative, this is O2 just O2 negative. We can easily see this is what we call a superoxide. So in superoxide, what you understand is there is no doubt the odd electrons are there. That's why definitely paramagnetic. So the correct answer is dia para. So dia para. I think D is the correct answer. What do you think? D is the correct answer. Of course, sir. If you solve any question, why would it be correct, sir? Every time you get the correct answer. But that is what I loved the most about today's day, guys. I was having this day terrible, and to be very honest, it's too much of running over here and there. You all know about RM is gonna to begin. RM is on tomorrow, which is the biggest educational fest we are having, and it literally eventually made me so tired, and I was just continuously watching your chat, and I just had a look, and somebody just posted over there, "Ki bro, you keep going on, we are with you." And I don't know, from out of nowhere this amount of confidence and this boost came in my mind, and now I'm feeling like I can teach you whole night even if it is possible to me. This kind of small things keep you energized and keep you always ready for facing the challenges. So thank you, guys. Let's come back to the topic, and let me have another such question on molecular orbital theory. Question is, so according to the molecular theory, orbital theory, that bond orders for oxide O2 2 minus CO NO positive are. So see, this is, let me just count the number of electrons, then I'll submit the correct answer. 16 plus 2, 18, 6 plus 8, 14, 7 plus 8, 15 plus minus 1 is 14. So the bond order will be 1, 3, 3. Do we have any option as 1, 3, 3? Yes, sir. 133 is A. मेरे गुनाहों में, मेरे सवालों में शामिल तू. Number of paramagnetic species: B2 para, Li2 dia, C2 dia, C2 2 minus, dia O2 2 minus, dia O2 positive, para He2 positive, para. I think 3 is the correct answer. How fast can someone be? Okay, I am fast, but I am not correct. Shah! This is para because it contains odd electron, man. Odd electrons, yaar. This is 4 actually. So eventually the aura got 999 positive and eventually reached to 999 negative. Yes. Let's see the another question then. But see, if somebody faces any kind of difficulty in finding out the bond order, magnetic behavior, and if you also want to solve these questions in seconds like me, you want to be expert like me, please watch my chemical bonding part 2. Molecular orbital theory has been explained there very well, in very depth and in very smart way, giving you 2 to 3 brahmastra to identify the bond order and magnetic behavior. So please watch that, because I also apply those brahmastra and I get to know these questions without writing the electronic configuration, literally without writing the electronic configuration. Okay, we'll take you to the next question. Now we have the next question, man. So according to molecular orbital theory, the number of species of the ion which are having identical bond order. Okay, first of all, let us write about the electrons. How many electrons does cyanide ion contain? 6 plus 7, 13 plus 1, 14. 7 plus 8, 15 plus 1, 14. 16, 15, 14. Let's see the bond order now. 3, 3, 2, 2.5, 3. How do I know? That is the trick, Ken. That is the trick. Sir, which college did you graduated from? I have completed my graduation from IIT SM Dhanbad. So that's it. My graduation was a BTech degree, Bachelor's of Technology in Mining Department, Indian School of Mines Dhanbad, IIT SM Dhanbad. 3 is correct answer. We were all right. Among the following, the number of oxides which are paramagnetic in nature. Which are paramagnetic in nature. Do you understand the meaning of paramagnetic here? So there might be some number of unpaired electrons. So let's see, let's find out where we can get odd number of electrons. So this is where we can get odd number of electrons. This is where we can get odd number of electrons. This is where we can, no, this is not odd. This is odd. This is O2 negative. This is odd. Na2O. O is actually no. Mere gunahon mein. I think 4. That's it. I don't see any other. Yaar, what should I do, yaar? Should I start calling myself the best out of it? Because I do the question in seconds like this, and I want you people to understand me. And please try the questions like me. Okay. Very good evening, Deepika Sharma. What a pleasant eve this is. So now I'll move to the next question. Among the following species, the number of species showing diamagnetism. Diamagnetism. That means there is no unpaired electron. Okay. If there is no unpaired electron, then how can you find the diamagnetism? We have 14 electrons here. First of all, I'll write down the electrons. Okay. So this is 14, this is 13, this is 15, this is 16, this is 16, this is 15, this is 17, this is 18. These are the number of electrons right now with us, and the number of species which will show diamagnetism. So diamagnetic species are the one which actually diamagnetic species are always even, but you must know that this is paramagnetic. This is something 16 electron species will be paramagnetic, but talking about this is also paramagnetic. Mere gunahon mein, mere sawalon mein shamil tu. This is diamagnetic, and rest are paramagnetic only. Is the answer 2? Sir, what should we do if you solve the problems like this in just few seconds? What should we do? So follow me, dude, and you can also become as much as fluent as I am in this topic. Anyways, aura minus 999. Another question from JEE Main 2022. The correct order of the bond order C2, 2 minus N2, 2 minus NO2, 2 minus respectively are. Let me first write down their electrons and then I'll tell you the bond order. Carbon has 12 and plus 2 is 14. Then nitrogen is 14 minus 2 is 12. Oh, sorry, 16. And there we have 18. So the bond order will be for 14 it is maximum 3, it will be 2, and for this will be 1. 3 to 1. So where can we get the maximum 1 increasing order? C to 2 minus, N to 2 minus, O to 2 minus. B is the correct answer. Solve this question in zup, like in seconds. All right. Enjoy and rejoice. Let's have another question from JEE 2022, which I am going to solve in just few seconds like this. We have some set of molecules. The question is saying which of the following atomic diatomic molecules are become stronger on basis of molecular theory after remove electron. Become stronger means increase in bond order. Where can you find an increase in bond order? If you remove an electron out of them. Okay, let us write their number of electron first. This is 13, no 13 sir, this is 15, this is 14, 16, 12, 10. If we remove an electron out of them, this has become 9 electron, 11, 15, 13, 14. The bond order will be 3, 2.5, 2.5, and 11 is how much? Oh, 10 it is 0. Bond order of 10 is 0. Sure, 10 is 0. No, 10 it is 1. 10 it is 1. So see, from 14 we started, so this is 1 for this will become what? Yeah. And this has become 0.5. 10 electrons were there. Sigma 1 is 2, sigma star 1 is 2, sigma 2 is 2, sigma star 2 is 2, and only 1. Yeah. And there we had the bond orders over here also. So for 15 electrons, initially the bond order was 2.5. We had 3 here, we had 2 here. We have 1 point. Sorry dada. 2 here. मेरे गुनाहों में, मेरे सवालों में शामिल तू. Now let's see where we are getting increment in the bond order. I think increase in the bond order, no? Arey yaar, where? Nowhere. Or this O2 is fine. One option, this is fine, O2. C is fine. A is fine. So A and C are correct, I think. Rest, I don't think anywhere we are getting increment. Woo! That's how we do. Let me take you to the next question from here. Consider ions in the molecules like O2 positive, O2 negative, and this. For the increasing bond order, the correct option is increasing bond order. First of all, let me write the electrons here. O2 positive, 15 O2, 16 O2 negative, 17 O2 2 minus, 18. Let me write their bond order. For 15 this is 2.5, 16 it is 2, 17 it is 1.5, and for 18 it is 1. So can we see the correct answer here? So O2, this is correct answer, I think A. Now I have solved this question in just 5 seconds. Can we see somebody solving this question in 5 seconds? Can I see somebody solving in this 5 seconds? Please try, follow me guys, and you will become as comfortable as I am, your chemistry wizard in chemistry. So let's make a deal then. What is the try? That's not try. Let's see this question. The spin only magnetic moment value for B2 positive species is this, and given is this. So B2. First of all, I'll find out the number of electrons. So number of electrons are how much? 10 minus 1 बोले तो 9 sigma 1s2 star 1s2. Actually the answer is 1 only, I know, and nearest integer will be 2. Can I see 2 answer? 173. It's foolish. No, fine. I'll show you. 1.73 is correct. Sigma 1s2 sigma star 1s2 sigma 2s2 sigma star 2s2 pi 2px1. So how many unpaired electrons can we see? 1. Magnetic moment will be root of 1 into 1 plus 2 is equals to 1 root 3 Bohr magneton, which is equals to 1.732, which can be written as 173.2 into 10 to the power minus 2. And what do you find the nearest integer with? So this is your correct answer. मेरे गुनाहों में 173. Number of paramagnetic species among the following given oxide. Now I'm feeling tired. I'm doing the same questions again and again. Yeah. Now it's making me sick. Number of paramagnetic oxides out of given oxides. Oh, man. Can I see? Chalo, now I'll take you from here to number of paramagnetic oxide. Very boring, man. Li2O, CaO, paramagnetic. So this is oxide. This is oxide. This is peroxide. This is also O2 2 minus. This is O2 minus. This is O2 minus. And this is O2 minus. Mere gunahon mein. The only paramagnetic oxide is this, dosto. The only paramagnetic oxide is superoxide. Superoxide. Where you can find superoxide? One only, right? A is correct, I guess. Another question. According to MOT, the number of unpaired electrons in O2 2 minus. So see, unpaired in O2 2 minus. Should be 0 should be the correct answer, I think. Then we have some set of properties mentioned here with the molecule. So which of them is diamagnetic? So NaCl is diamagnetic. NaCl is dia. Ferrimagnetism. Ferri. Paramagnetic is O2. Now antiferro magnetic and ferro, I don't know, because okay, I'll use the option elimination. Where can we see A23 and C22? So A23 C22, this is incorrect. A23 incorrect. A23 C22, this is correct. A23, this is also incorrect. See, I got the correct answer now. Now using this I can tell you B, ferrimagnetism, as actually this what we call it, Fe3O4, mixed iron oxide, we call it magnetite. So C is the correct answer. C. Now the bond order of O2 minus ion. So O2 with a minus charge, how many electrons are there? 16 plus 1, 17 electrons. 17 electron will be having a bond order of, so right, we are deviating from 14 and we'll keep on decreasing the bond order by 0.5 after any increment in the electron. So the bond order will be coming up as 14 to 15, 1 2 3, 1.5 is the bond order, and no doubt this will be paramagnetic, because anything which has which is odd electrons, that has odd electron will definitely have something that has odd electron will definitely has unpaired electrons. Correct answer is 1.5 and para A. The total number of electrons in all bonding molecular orbitals, of O2 minus is total electrons in bonding. This is actually how many electrons are there? 16 plus 2, 18. So 18 electrons are sigma 1s2, 1s2. Sigma 1s2, sigma is done now. Then we have pi star 2px2, pi star 2py2, sigma 2pz2. Let me check how many electrons have I filled. 2, 4, 6, 8, 10, 14, 14 and okay. We have 14 electrons plus 2. 16 plus 2, 18. So I think this should be 0. Now the question is how many bonding electrons in bonding molecular orbitals? 2, 2, 4, 6, 8, 10 electrons in anti-bonding molecular orbital. 2, 4, 6, 8. So that's why we are getting bond order as 1. Even if you want to find out the bond order will be 1. So the correct answer is 10. 10 actually what we have decided. Let's see another question from JEE Main 2021. Difference in the bond orders of CO and NO positive is x by 2, where x is what? Okay. So difference in the bond order. CO and NO positive. CO has 6 plus, this is 14 electrons. This also has 14 electrons. So I think 0. 0 is correct. Now, in the following correct sequence is O2 2 minus. Okay, that's what we have done. O with positive charge will be having more, and negative charge will decreasing. C is correct answer. Without solving, I can submit the correct answer. AX is a covalent diatomic molecule where A and X are the second row elements of periodic table. Based on the molecular orbital theory, the bond order of AX is 2.5. Then the total number of electrons in AX is what? Nice here. The bond order is 2.5. So do you know maximum bond order is of? Maximum bond order is 3 with an electrons of 14. So for 2.5 it could be either 15 electrons or it could be 13 electrons. Now we'll have to check. AX is covalent diatomic molecule, covalent and also diatomic molecule, and A and X are second row element, second period element. So based on the molecular orbital, the bond order is this. Then total number of electron is, I don't know man, how come it could be 15 also? No, is a covalent diatomic molecule. A are second row. So basically A and A, these are different also. Okay. So with 13 electron we can form, no, with 15 electron which species can be formed? I guess nitric oxide. But with electron this we can form carbon monoxide. No. Carbon monoxide is not possible. I think this is the only possibility. 15 is correct answer, boss. I tried to make some molecules out of 13 electrons, but not possible as such because we didn't find any heteroatomic molecule. Okay. No, even any molecule is not possible to make out of 13 electrons, and carbon would have gone there. Carbon and not possible here. 13 electrons. Leave it. No, this is fine. Only possible is 15. Then we have to match them with the bond orders, which is another very easy question to all of us. It's like extremely easy. We know the number of electrons. I'll first write down the number of electrons. Neon 20, 14, 18 and 16. 16, okay, so 20, 0, 14, 3, 18, 1. Use my Brahmastra, guys. Those who can't solve the question like me, you need to better visit my theory lecture first. Read out complete molecular orbital theory. You will become as confident as I am in this topic. 16 ke liye it will become 2. Now check out the correct answer. A3, B4. A3, B4. I think C is correct. A3, B4. मेरे सवालों में, मेरे जवाबों में शामिल तू. So next question is, according to molecular orbital theory, species that does not exist is beryllium 2 because the bond order is 0. Anything that has bond order 0 will not exist. Now I'm feeling tired, man. So do anyone want to ask me anything? You may ask, else I'm leaving, guys. Actually, I'm feeling lots. uh, I'm dead now. Nitric oxide and this minimum bond strength is will be given by electrons. Nitric oxide 15, 14, uh, 7 and 8, 15 minus 2, 13. The bond order will be 2.5, 3, 2.5, 2. This is the correct answer. Minimum bond strength. मेरे सवालों में मेरे जवाबों में okay. 1.73, which if the magnetic moment of dioxide species 1.73, it may be what? So number of unpaired electron is, I told you this trick, that whatever the 1.73 is there, this first numeral will show you the number of unpaired electron. And yes, for all these A is correct, because all these species which will be having unpaired electrons, and usually the odd number of electrons will be there. They are having one unpaired electron in molecular orbital theory of up to our syllabus we have studied. Then we have bond order of the metallic cyanide. Man, how many electrons does it have? 6 plus 7, 13 plus 1, 14. Bond order is 3, and it is diamagnetic. These are some sort of similar kind of question that I would expect you people solve them by your own. I think that's it, which I wanted to teach you. You can solve some more number of problems have been given over here. Not too many, but yes, a few of them are still left. JEE 2018 and then 16, and then because every year so many questions from molecular orbital theory has been asked. See, 13, then we have a huge gap, and finally there is thank you. So instead of saying thank you, you better guys, please attend this RM event, okay, which is gonna to start in just 21 hour, just in 21 hour. So what I should say now? First of all, do one thing, notify, and then like this session. मेरे सवालों में मेरे गुना